In this lesson, we are going to create a game with React 3 Fiber. And you can see the game running right here, so I can show you the final results with cool effects and everything. At first, we won't have like reflections and depth of field, but we will add those at the very end of the lesson. And as you can see, we play like a ball, so it's a marble, and we have to go through the whole level as fast as possible. So I did 10 seconds, which is not great, and everything is generated automatically. All right. I'm going to close this one and start with the starter. So yeah, a few information about that game. The player can move the marble and make it jump with the keyboard. Okay, I've been using my keyboard. You can use. We will go in details later. As soon as the marble starts moving, the timer starts. Okay, the timer stops when we reach the end, so that the player can see how long it took to finish the level. And a restart button appears. Clicking on it, reset the marble. Okay, and it resets the time, and the user can start playing again and again. And by the way, the level also changed. There are more features. Maybe you notice them, but that's the general idea of what we want to achieve in this lesson. About the setup, it's near the usual setup with a sphere, a cube, a green floor. There are some lights. By the way, the lights are separated in a different component. So it's the lights component right here. You will see why later we will have some code related to the lights, so it's better to encapsulate it in different components. We have the shadows. We are going to make sure that they work, and I've also changed the light settings, you know, the shadow map, so that it's a bit bigger and looks a bit better. We already have Dray, okay, so that we can rotate around with the orbit controls. By the way, when you create a game, you should definitely add a debug UI like Leva and performance monitoring like perf. I didn't add those because I know where we are going, but during the process of creating the game, I used those in order to find the best colors, values, and to make sure that the performances were fine. So when you create your game, add those. And if you want to improve that game at the end, because you can improve it so much, add Leva or something like this and perf. And we're going to start with the level. Well, because I think when you create a game, even a small game, it's better to just have something on screen as fast as possible, so that you can already see it and enjoy it, and it will help you think about it and add features on top of it. Our level will be composed of blocks. I can do some drawings. Let me show you. Up, up, up. We will have the entry block, so I'm going to draw it like this. So this will be the start block, in which we will have the ball like this, and then we will have a bunch of traps blocks like this. Traps blocks. We will be able to control how many of those blocks we have, and at the end we will have the end block like this with a hamburger, as you saw previously. And on those traps blocks, each one of those blocks will be a trap. So it can be, I don't know, like a spinner like this. It can be a big things going left and right like this. This one is rotating, and the final one will be something like that will go up and down. Okay, that's the idea. And we will be able to create, I don't know, like 10, 20, and control that super easily. And that's the finish line. So that's the global idea, and we're going to create those blocks one by one. Okay, yeah, that's what I just said. We're going to create 3 different traps and use them randomly between the start and the end block, so that every time we play, we get a different level. Let's go. We're going to create in different components. We will have quite a lot of code. It's okay, thanks to React 3 Fiber, but still, because we're going to have quite a lot of code, it's better to separate it in different components. And we're going to start with the level component, so level.js. And in that level.js, we are going to export the usual function component, so function level like this. And in there, let's be lazy and simply return this, okay? Our 3 meshes from the experience.js. And I'm going to put them, I'm going to close the light. So in there, so return, I'm going to add a fragment like this and return the 3 meshes, okay? Export default function, not function, what the hell? I guess you fixed it already. Back to experience.js, we're going to import this one. So it's going to be import level from level.js. Later, we're going to change how we import the level. You will see why. And in there, I'm going to simply add it to the JSX like that. Okay, so that we have an experience.js file. Super simple. I think it will still be simple. You will see. Okay, nice. We get the exact same result because we created the meshes, but inside the level. We're going to add physics. As you can see, it's a physics-based game, which I think are the best game, but depends on the gameplay and the mechanics you have. The game will rely heavily on physics, and we're going to use Rapier, obviously, that we learn in this chapter. And we're going to use React 3 Rapier as in the previous lesson. So let's go. We are going to open the terminal. I'm going to open a new terminal. I still have the server running, npm install at React 3 / Rapier, and we're going to use the version 0.9. We force the version so that we have the same result. Feel free to update it, but be careful, you're going to have differences and probably syntax differences, like API differences. You will probably need to write it differently. I'm going to close this terminal now that it's installed. You can ignore vulnerabilities as always. And I still have the server running, and now I have access to the library. So the React 3 Rapier. We're going to add physics at a very high level because we are going to have a bunch of components that need it, not just the level. Later we're going to add a player. The player will also needs physics, so it will be we need to add physics at the top level. I'm going to import it, and we're going to import the physics and immediately import the debug too, because we are going to use the debug so that we can see what's happening. 3 Rapier like that. Okay, great. Then we're going to wrap our lights and level in this one, so physics like this, and we are going to add the debug like that, so that we can see the debug versions of the physics object of the rigid body. And we can start with the start block. Makes sense. It's going to be very simple. It will be just a floor. All right, I can show you the beautiful drawing I did earlier. It's just that. Later we're going to add more stuff, but for now we just want a simple floor, a bit like this one. So component, in order to keep things well organized and reusable, we're going to put each type of block in a separate component. Those components don't need to be in a separate file. By that I mean that the block start, the block end, the block traps, etc. can be in that file here. Usually I always separate, but I wanted to show you that you can do that, and in this case it totally makes sense, and it will be quite an interesting structure you will see at the end. So let's go. In the level.js, so make sure you are in the right file, we are going to add a block start like this, just like that. For now we are not exporting it, we are just going to use it inside the level right after, and you can do that. Then in here we're going to add our block start. So for now, is it returning something? Yeah, we need to return null. Okay, your component need to return something, and if you want to put nothing in it for now, you just return null. And in there we're going to add it. So let's go block start like that. Okay, we added the component, but there is nothing inside it. In there we're going to create our floor, and we're going to use a mesh, and it will have thickness. All right, remember from the previous lessons about physics, and planes without thickness, it's bad for physics, so we are going to add some thickness to each one of those planes. All right, we'll just do those two here. So let's go. We're going to use a box geometry like this. You can use my args. Each block will be 4 units. All right, I can draw it because we are going to need that information quite a lot. Okay, this one here is 4, and this one here is also 4. It's 4 by 4. We are going to put that 4 number quite a lot in the code, but you will be able to improve it, and you will see how later to have that number in a very specific position. Where is that position? You will understand later. So let's go. We have 4, 0.2, and 4, and we can actually test that, and we get this. All right, we didn't add the material yet, so mesh standard material color, and I'm going to use lime green for this one here. There will be a difference between the start and the end. It's not going to be white. It's going to be a different green. All right, next, what do we have? Lime green. I think we are okay with this one. We are going to move it down so that the 0 of the scene. I think the 0 is right here where my cursor is right now. The 0, 0, 0 of the scene. We want the top part of the floor to be at 0. Okay. I can do a quick drawing. We might use it later, so it's going to be useful. So right here, the 0, 0 of the scene is right here, okay? And I want my plane, so this one, tac, tac, to be like that. So that we can, it can be useful to have 0 coordinates. That makes sense. It's the floor. When you want to place something, it gets easier, although it's not that important right here. It's still good to do that. I don't know why I'm going that much into details. Just lower it. To do that, we're going to do it with the position like this. You can just do position Y, 0 minus 0.1 because the thickness is 0.2, so we half of it, and then 0, and it would move slightly below. Okay, that's the 0 of the scene, which is right here where my cursor is right now. We're going to add receive shadow on it. We can add it at the end, why not? Receive shadow like that. Okay, so that the shadow is casting on it. Shadow is quite an important topic in this lesson, you will see. We don't need to cast shadows because there will be nothing below. I know there is something right now, but we are going to get rid of it right now. So get rid of those 3 meshes. It was just to make sure that we have something on screen. And here we go. That's the start of your game. We have a lot to cover. Remove the previous scene. Yeah, that's done. And then we're going to handle how we position things. So the start block will be at 0. Okay, the origin, we will decide that the origin of the whole level will be right here. Okay, that's the 0, 0, 0, 0, 0, 0 of the scene. Okay, so our start block is at the right position, but we're going to be able to move all the blocks, and we want to code them the same way. So we will be able to choose how to position the various blocks. So for now, we just have the block starts using a position attribute, so that when we have a bunch of blocks, it's not going to be the block starts, but the block end, etc. We will be able to move them through a prop, I mean an attribute. So let's go. First, we're going to retrieve that prop right here, and we're going to call it position equal and set the default value to 0, 0, 0, so that if we forget to set it, it will work. Okay, we will have the 0, 0, 0. Next, we're going to use that position, but not on the mesh. We're going to add a group around it like this, up and up, like that. And we're going to send the position, so we can do position, position. Yes, we could have spread the whole props, but I don't know what we will add later. Actually, there won't be any more props to add, but I like to just send the only prop I want, which is the position, like this. The group currently is useless, okay, because we only have a mesh. Why did we add the position on the group? We could have added to those values here. It's because later we're going to add a bunch of stuff in there, and the other blocks will have obstacles, the hamburger, etc. So it's better to encapsulate each block in a group. So right now the idea was that we can control the position of each block. So for us, it's the block start, by setting other coordinates like that, and it just moved toward the camera. Okay, doesn't make sense to move it there. The default value is just fine, so we're going to put, I think, 0, 0, 0 or nothing. It's up to you. I'm gonna put 0, 0, 0. Okay, cool. Let's move forward. We will add the walls. If you remember from the examples, the example that I shown you, there are walls on the sides. We will add those at the end, so that we can just add one wall on the right that go to the end of the level, one wall on the left that goes to the end of the level, and there is one also at the end of the level. So no walls for now. Let's do some optimizations already, yes, because it's to anticipate what is going to happen. At the end, we will have a bunch of blocks. All right, you get the idea. There is a bunch of blocks. You will see that they will have a bunch of geometries and materials, but most of them are the same. The material for this floor is the same as this one, is the same as this one. The material for this floor is the same as this one. Most of objects that compose the scene are most of geometries are box geometries. This one is a box. I'm talking about this obstacle. This one too. This one too. The floor is a box. This one is a box. This one is a box. So we are going to optimize that only creating what we need at first. We're going to create only one box geometry and use that box through the whole level, not for the ball, obviously. So let's go. we're going to instantiate one box geometry outside of the component, and we're going to do it in native JavaScript because it makes sense, I think. So let's go outside of everything. Right here, we're going to import all as 3 from 3. As always, you can just import the classes you want, but I'm going to import everything from 3. Instantiate one box geometry. So let's go. We're going to call it box geometry. Makes sense. New 3 box geometry like that. And I'm going to set the size to 1, 1, 1. Does that mean that everything will be a size of 1, 1, 1, like the floor 1, 1, 1, the obstacle 1, 1, 1? No, you probably guessed how we are going to fix that. We can save, no issue, great. And in the mesh, so for now we only have the floor for the block start. Instead of creating it right here, we're going to set it through an attribute. So it's going to be geometry. That's the other way of setting a geometry on a mesh. Geometry like that. Give it a reload, or I did a mistake. Geometry. Oh, sorry, box geometry. My bad. Like this. So obviously now it's a 1, 1, 1 box. To fix the shape, change the scale on the mesh. That's all. If you want to reuse the same geometry, you put a default value. 1, 1, 1 makes sense. And then you change the scale directly on the mesh. So let's go. We're going to change the scale and we are going to add it after the position. So right here, scale equal. I'm going to send the same value as before. So it's 4, 0.2, 4. And I did a mistake. Yeah, you need to use curly bracket like that. Like this. Okay. As you can see, we have quite a long line right here. I'm going to keep most of them in one line because we will have a bunch of code. It's up to you. If you want to add line breaks, pause the video, add line breaks. I actually prefer to have line breaks, but this code will get quite big. And for the lesson, I thought it was maybe better to keep some of those in just one line. It's up to you. You do whatever you want. By the way, I'm not adding a lot of comments, but usually on my personal project, I add a bunch of comments. Like this one would be floor, and this one I would add probably a block like this. It's a way of commenting which can be used for documentation, etc., explaining what this component is doing. I'm not doing that because I don't have much room in there. You should do it. Next, the materials. We're going to do the same for the materials. There is 4 materials. There is, there is more, but for the level, there is 4 materials. This floor, this obstacle, and I think the walls have a different material too. So 4 materials. Let's go. We're going to create them right away. Yeah, floor 1, floor 2. I wasn't very inspired for the names. Obstacle and wall. And we're going to use those colors. So lime gray, green color, orange red. I think it's orange red, slate gray. Yeah, spent probably half an hour choosing those colors. I hope you will like them. Anyway, you can change those the way you want. So floor 1, I'm going to do it with you. I'm not copying and pasting the code below. New 3 mesh standard material because we want it to react to lights. We're going to provide a color, and so this one is going to be lime green. This one will be used for the block start and the block end. So this one here. I can give it a save just to make sure that I haven't done any mistake. Floor 2 is going to be green, yellow. Oops. Green, yellow. Come on. Next is going to be the obstacle, so the red obstacle. I put red because it makes sense. It's something we should avoid. Orange, red. I mean, not red, orange, red, but they look reddish. Wall material. I think they are kind of gray. Yeah, slate gray. I love that color. I have no idea actually how it looks. And we can save. And instead of creating a material like this, we are going to send it just like we sent the geometry by doing material equal floor 1 material. Okay, that's a very long line. You should add line breaks. You do whatever you want. I'm going to save, and we get kind of the same result. We have 2 things to fix. First, we can auto close the mesh. Okay, there is nothing inside, no reason to have a useless line like this. So auto close it. I've added the slash at the end of the mesh. Make sure you see it because I'm gonna scroll. Let's scroll. We get the same result, and something weird is happening with the color. Like sometimes it's the right one, sometimes it's brighter. What is happening? You might notice a difference, okay? This is due to how Three.js and React 3 Fiber handle the encoding of the colors. I'm not going to go into details, but when you use only React 3 Fiber to create everything, React 3 Fiber takes care of the color encoding. great. But when you create stuff outside, sometimes well, the encoding isn't set right, especially because 3GS has a very specific way of handling colors. It's something new actually. They added it, I think, 1 year or two ago. It's called the color management. And we are going to deactivate the legacy mode, kind of the old mode of using colors. Now we wanted to use the new mode. So to do that, we are going to do it in here. So it's outside of everything. We're going to tell 3GS that for its color management, to deactivate the legacy mode by setting it to false. Legacy, not legagi. Whatever. It's just the beginning. I'm already doing mistakes. And now you can refresh. You can use the hot module replacement. You will have the right color. So it's working nice. Usually you just put that, okay? If you are creating colors, materials outside of React 3 Fiber, just add that and everything will be fine. We are done with the first block and we did already some optimization, and we can start with our first trap. The first trap will be, I think, this one is the spinner. Why this one? Well, because it's what we did in the physics lessons. We are going to just make it spin. And actually, maybe you should try to do it yourself if you want to practice. I know that's a big lesson. Maybe it's not a good time to add some personal practice. It's up to you, but try that. Quite a hard exercise. Create a new component. I forgot the name. Call it maybe a block, a trap, spinner, or something like that. Anyway, you can change the name after. And you should create a spinner, bread spinner, doing spins like this. Okay, turning like that. Try to do that. Quite a hard exercise. Let's do it together. First, we're going to be lazy and duplicate the block because the floor is the same, and we're going to duplicate it below. Okay, I have the block start here. I'm going to create a new block here and I'm going to call it block spinner. So the name was block spinner. We can keep the props and everything is kind of the same. Next, let me see. We are going to instantiate it right here. Oops. So after the start, we're going to instantiate the spinner. And right now they are at the same place. What we're going to do is move the start back a little. So this one here, back, it's 4, okay? Because it's negative when going forward like this. This is a negative Z. This is positive Z. So we put 4 on the block start, and now we have 2 blocks. This one is the spinner block. This one is the start block. In block spinner, set the floor mesh material to floor 2. Yes, we have different materials. So let's go. This one here, make sure you're in the block spinner. We set it to floor 2. Okay, so that we can differentiate the start and the traps. It's kind of grass, low poly grass. Obstacle, let's create the obstacle. So let's go. In there, so that's why we put a group. In there, we're going to create the obstacle. For now, we don't care about the physics. As always, when you create something intended for physics, first you create that object. Then you add physics. For the geometry, as I told you earlier, they are composed of box. So we're going to use the box geometry that we created before. For the material, we're going to use the material that we created. So it's going to be the obstacle material. And we already have something on screen. Nice. Then we're going to play with the scale. So it's going to be, for now, we don't play with the position yet. It's going to be 3.5, 0.3, 0.3. What do we get? Yeah, like this. It's like wide enough to make sure that the player can't go just on the side like this. Nice. We can set the cast shadow and receive shadow attributes. So I'm going to put them at the end. I like to always use the same order so that you can easily see geometry, material, position. There is none on this one. Scale, receive shadow, cast shadow, etc. So let's go. So cast shadow, receive shadow. Try to code always the same way. You will thank me later. Next, we have our obstacle. We're going to add physics. So obviously it's inside the floor, but for now we don't care. We're going to move the rigid body. So first we import rigid body. Remember that we already added the React 3 Rapier library. Import. By the way, you can rely on the auto import of VS Code. I'm doing it like this so that people that don't rely on the auto import of their code editor understand when I import things. React 3 Rapier like that. Next, we're going to wrap the mesh, so the obstacle, like this. As always, you should add comments. So it's going to be this one here and this one here. What's going to happen? Maybe you can guess. It's going to fall, okay? Because there is nothing below stopping it from falling. Should we add a rigid body on the floor? No, not yet at least, because we don't want the spinner to just fall on the floor. We are going to move it ourselves. Maybe you can guess what we are going to use to move it like this. We are going to use the kinematic position. Just like in the physics lesson, we want it to do the same rotation, and we don't want it to slow down if something blocks it. We want it to just turn always at the same speed. So let's go. On this one, we're going to add the type. Type kinematic position. And it's going to be a code very similar to what we did in the physics lesson. We're going to move it up directly on the rigid body. If you give it a reload, it won't move anymore. It's kind of a fix, but a fixed that we can move and rotate. Position, we're going to move it up slightly. It's going to be 0, 0.3, 0. We're going to set its restitution to 0.2 and friction to 0. Why? I will tell you right after. So first, restitution. It's going to be 0.2, still on the rigid body. Make sure you are still adding code to the rigid body. And friction, we're going to add 0. Why? Well, so that the ball, because remember we will play a ball at the end, will bounce just a little on it. We don't want it to bounce back and to go back at the beginning of the level. So just slightly bounce so that it's visually correct. And friction to 0, because we don't want the ball to rub on it too much and the player to get stuck, okay? The punishment is just that you get pushed back, that's all. To animate it, we need a reference. So let's go, we are going to create a reference by using React. So import use ref from React, like that. And then we're going to create an obstacle reference. I'm not calling it spinner because we're going to create, or twister or whatever. We're going to use the same code for other traps blocks, and it's cool to have always the same names. So obstacle equal use ref, and then we can associate it with our rigid body with the ref, right? Nothing new in there. Nice. Next, we're going to animate it on each frame, meaning that we need the use frame from React Free Fiber. So import use frame from React Free Fiber, like that. In the block spinner, so in there, we're going to call it like that. I'm getting a bit ahead, so let's go like that. We need to retrieve the state because to animate it, we need the time spent. We are doing exactly what we did in the physics lesson. We need to get the time spent since the experiment started. So it's going to be in seconds, 0, 1, 2, 3, 4. And we are going to use that as the angle to rotate our obstacle. So we can get it from the state and we can retrieve the time by creating a new variable time and doing state clock and use get elapsed time. This one here, and you can log it to make sure that it's working. Check that. And we get this. If we reload 0, 1, 2, etc. By the way, you can also write elapsed time like this. I should check the code and see what's the difference between those. It's up to you. Let's do a method this time. To rotate the spinner, we have to use the set next kinematic rotation. Okay, we've seen that already. But this method is expecting a quaternion. So we're going to do some tricks. We're going to create a Euler like this. We are creating directly in the set from Euler that we call on the quaternion. So let me do it again. We create a rotation variable, which is going to be a quaternion because that's the one that we are going to send to set kinematic rotation. Then we create a Euler using the time, so this one here, and we set it to the quaternion by using the set from Euler method, like in the physics lesson. So let's go, I'm going to remove the console log, and we're going to add the rotation. So const rotation equal new 3 quaternion, like that. Rotation set from Euler. I'm not creating the Euler in a different variable, but you can do it if it makes more sense for you. New 3.Euler. That's probably not how we say Euler. Anyway, I like to say it like that. And then we use that rotation. We can give it a reload just to make sure that there is no error. Now we can send it to the obstacle. So obstacle current. Don't forget the current with the references. I always forget this one. kinematic rotation. What a long method name. And we send the rotation, which is a quaternion, just like expected by this method. And it's rotating so easy once you know how to do it. Unfortunately, the rotation speed is good, but if we had a bunch of block spinner, they will act the same way. Don't do it. I mean, you can do it with me, but you can just watch my screen. I'm going to show it to you. Check that. I had a second spinner, and see, they are rotating at the exact same pace. If I had 8 to this one, so the third one, they're rotating the same way, which is not very good in terms of gameplay. So we need to add some randomness to it. To do that, we are going to create a random value in there that we'll then use to change the time right here. So instead of just using the time, we're going to multiply by a random value, but we just want to create it once when the spinner is being created for each component. And we've seen that, you know, when we played audio. To play the audio, we used use state. It's kind of a trick, a weird way of using the use state, but it will just create a value that you can use. It will create it just one, and you can use in the component, and another component will have a different value. So let's go. It will make sense once you see what I'm talking about. So use state like this, and in the block spinner, we're going to use it to create a new state. We just need the value. It's going to be speed, like that, and we call use state, and to that use state, just like for the audio, we send a function, and that function is going to return where we just want a random value. So we're going to return math random, and check that, we just get the speed, a random speed. But if the component is being re-rendered, whatever the reason, our components should not be re-rendered, but we are going to rewrite it the right way. Okay, if the component is being re-rendered, the speed will stay the same, and then we can use that speed. So the speed is not very good yet, but let's just use that random value. We multiply the time by the speed, okay, the speed that we just created, and we get different results. If you give it a reload, a different speed, a reload, a different speed, a reload, a different speed. And if you add a bunch of spinners, they will have different speeds. But first, it can be super slow. See, right now it's probably like 0.1. It's a bit too slow, so we're going to add plus 0.02. So in the use state, I add 0.2 so that they can't be slower than that. Okay, let's give it some reload. That's probably near the slower that we can get. Okay, it's always fast enough. The rotation is quite good, but it's always in the same direction. How can we fix that? There are multiple ways of fixing it, but I want to show you this one here. We're going to use another math random. If the value is below 0.5, we multiply this by -1. Otherwise, we multiply it by 1, meaning that half of the time, statistically speaking, half of the time, it will be multiplied by -1, so it will go the other way. And the other half of the time, it will go the same way. Makes sense. So let's go. We're going to multiply and put some parentheses. Yeah, by the way, first multiply this one. Put parentheses on this one. So watch my screen. The math random plus 0.2, we put parentheses on this one. And this value, so make sure that your cursor is at the right place here, we multiply it by what I've just said. So it's going to be another math random. And we are going to use the ternary condition. If it's below 0.5, so we put the question mark, we multiply by -1. Otherwise, we multiply by 1. I know it's a bit tricky if you're not used to using ternary like this and ternary condition and use the math random like that to invert it, but just watch it, separate it, and it will make sense. This whole part here will be sometime -1, sometime 1, and we multiply this with the initial value. So sometimes it will rotate in one direction, sometimes another one. There are other ways of doing that. I just wanted to show you this trick. Next, this one is ready. That's great. Next, we are going to create, and see, I give it some reload. Sometimes it's one direction, 4 times it's the same, in the same direction, obviously. But you get the idea. Sometimes in one direction, sometimes in the other one. We can switch to the next one, and I call this one the limbo trap. Why limbo? You know that game when I'm not going to do it right here. So you have to go through a bar like that, and go below that bar. And the bar will go lower, lower, lower. So it's a bar doing that, and you need to go below that bar. That's why I call it limbo. You can call it whatever you want, like, I don't know, like vertical door or whatever. So first we're going to create the component, and we're going to be super lazy by duplicating the whole block spinner because it's a very similar one. See, they will be very similar. Those are doing kind of the same things, but one is rotating, one is translating, and the other one is just translating in the other direction. So take your whole block spinner, make sure you're taking the whole block spinner. Watch my screen. Okay, it's from this to this, and duplicate it. So we have two block spinners right here, and name the second one. So this one here, this is the first one, this is the second one. Name this one limbo, like that. For now the code is exactly the same, and we're going to instantiate it here. So we're going to add a new one and call this one limbo. So this one will be 4, so change the z of each one, and this one will be 8. So that we have, give it a reload, the start, the spinner, and the limbo. And obviously the limbo needs some changes. So let's talk about the animation. We want the obstacle to move up and down, okay? The player will be able to jump above it or to go below. Instead of using set next kinematic rotation, we are going to use the other one, which is set next kinematic translation, to be able to change the position. It's weird that they call it translation. I would have used position. They probably have their reasons. Since we want the obstacle to go up and down forever, we can use a sinus. Why? Well, because I can show it to you again. Sinus the x looks like that. See, it's a value that will go up. By default, it's from -1 to 1. So -1, 1, -1, 1, and we're going to send the time to this one. It will work perfectly, and then we will tweak the value so that it's above the floor. If you want to practice, now is a good time again. You can pause the video and try to do the limbo obstacle yourself. Let's do it together. So make sure that you're working on the block limbo. We're going to handle the animation right here, and we're going to remove those because we still need the time. Okay, so we just have the time right now. I'm going to create the y value because we want it to move on the y axis by creating a y variable and use math scene and send the time to it. So this one here. If you test that, check the result, we get something from -1 to +1. -1, very near to -1, +1. Oh, sorry, the opposite, +1, -1. So it's doing this. And we're going to use it on the set next kinematic translation. So obstacle current, don't forget the current, set next kinematic translation. We send an object. It's a vector 3, but we can just create an object. On the x, we put 0. On the y, we put y. You can just write y like this in that case. Okay, I'm not going to do it. And on the z, don't do it actually. You will see why. We put 0 and check that. It's already working. Yay! But it's from +1 to -1. Okay, great. We can move it up slightly by changing the y. Actually, you can write the y. I was wrong. You can just write it like this if you want. It's going to work. Plus 1.15, so that it's above the floor. Always. Let's make sure that it's working. See that? Yeah, perfect. Okay, implementing a bunch of block limbo will result in identical animations. You don't have to do it, just watch my screen. You can do it if you want. -4, check that. No, actually, I'm not going to do it to show it to you for a reason that we will see later. Anyway, when we will have a bunch of limbo, they will all move the same. They will just do that all together, which is a bit weird and not very interesting in terms of gameplay mechanics. So we are going to do kind of the same thing we did for the speed, but instead, so the speed of the block spinner, instead of the speed, they will, this time to vary a little, they will have the same speed, but they will be offsetted in time. So they will do the same animation, but not at the same time. We're going to call this one time offset. So time offset, and be super lazy and just do a math random multiplied by math pi. Math random multiplied by math pi, sorry, multiplied by 2. It's to make sure that a sinus, if you want to offset it, it's quite hard to explain, but those waves we've seen right before, those waves here, if you want to make something random, see, it goes from, before doing the same pattern, it goes from 0 to 6 point something, and maybe you guessed it, this is 2 times pi, okay? So if you want to offset that pattern through this whole pattern, you need to multiply by, you need to multiply the math random by this value here, so from 0 to 6 point something, so from 0 to math pi multiplied by 2, which I think we call tau, by the way. I don't think we have access to this one in JavaScript. Let me check. No, it's not working. You need to do it yourself. Okay, great. So we created that state, but we are not using it yet. To use it, all we need to do is add it there, okay, to the time. So which is the x of the sinus we can see here. We add that random value right here. Let's go. And it should work. Okay, let's just think that it will work. We'll add the block spinner, the other blocks later. The block limbo, sorry. We made a small mistake, and you can see it if you try to move them in preparation of adding the third trap block. Let's say we want to move this one back a little, so it's going to be 12, this one is going to be 8, and our block limbo, we're going to put 4, so that we can add that new block. But check that, give it a reload, see the issue? That's our block limbo, and the obstacle is right here. Okay, so there is an issue. The issue is that we provided values, so in there, in the set next kinematic translation, we provided those values, and those are absolute values, meaning that the obstacle will always be at z0. It will always be in there. So we need to fix that, and the fix is quite easy. We already send the position of the block in there as a props, but we're going to use it in there. So we're going to do position 2, which is the z, like this, and we just need that. Check that. Now it's moving with the block. Okay, and if you provide a different value here, it's just this value here. So it's going to be a 4, and 4 is right here. And we're going to do it on the x2 in case you want to move them laterally. Okay, the level will only be on the z, but if you want to do something funnier and move them for some reasons on the z, on the x, it will work. And we will do the same for the y, just in case, I don't know, you have multiple levels, some stairs or whatever. We will do position 1 plus y. Okay, check that here. Position 0 is the x, position y is the position 1 is the y. Don't forget to add the y animation, and position 2 is the z. Nice. Let's move forward and do the last trap. Quite easy. It's the axe trap block. Yes, I know this one doesn't look like an axe, but I was thinking of doing something that would look more like this. You know, in dungeon games, you have some kind of huge axe like this, and this one is doing like that. That was the idea. I wanted to do to make something fast, so I just created this silly block that goes left and right. But the idea is that it's supposed to represent an axe, and you can create an axe if you want. It's not that complicated, but the lesson is already big enough, as you can see. Yeah, okay, you get the idea. It's going to move left and right. And we're going to create the component just like we did for the block limbo. So take your block limbo, start from the block limbo because it's exactly the same one, but with a different shape, and it's moving on the X. So take your block limbo, duplicate it, and we're going to name it block axe, just like that. Next, in there, we already moved them, so make sure that you have the same values. You know, it was to show you what happened when we moved the block limbo. So 12, 8, 4. And we're going to create the block axe right here and position it at the center. So it's going to be 0. And that's our block axe. The shape, we're going to make like a bigger, kind of a big wall that will move left and right. So I'm talking about this one here. Let's go. We're going to change it on the scale of the mesh in the rigid body. So it's this one here. So make sure that you are on the block axe. Make sure you are in the rigid body. And make sure it's the mesh. And it's on the scale property, the scale attributes. And we're going to put 1.5, 1.5. So X and Y are going to be just a kind of a rectangle. And for the thickness, it's going to be 0.3. And we get something like that. Nice. You can do the animation yourself. I'm quite sure of it. Let's do it together. We're going to move on the X. So it's going to be this one here. Like that. We're going to remove the plus 1.15. Let's see what we get with just sinus with the time offset thing. And we're going to add it not to the Y, so this one here, we can remove this part here, and we're going to add it to the X, like that. And now it's moving left and right, so cool. Obviously it's in the floor, we're going to move it up by adding a fixed value, so it's going to be right here, we're going to do plus 0.75, like that. Okay, it's I think it's like right on the floor. Let me check. Yeah, see, it's right here. You can move it up slightly or maybe whatever. It's not that important. Increase the amplitude. Yeah, let's see. No, the amplitude is fine, but we're going to make sure that the blocks goes at the very edge of the level, so near the walls. And to do that, we will just multiply by 1.25. So the x, the math sign, we multiply by 1.25, and now it's going at the very edge of the level. Why not? So yeah, we are done with the trap blocks, but obviously you can add a lot more. The lesson was already so big, I had to stop there. I think 3 is enough to create something random, but have fun, create a bunch of traps. Maybe not right now, maybe after we finish the lesson, but have fun with that. And now we need the end block. Okay, so we have the start block, we need to add the end block. We are going to create the component and we're going to use the start block as a reference. Okay, this one here, you're going to duplicate this one and we're going to name it block end, like that. We're going to add it. So again, we are positioning them manually. It takes time to position them, but don't worry, this will be automated at some point. So 16, 12, 8, 4, and then we can create the block end like this, and we put it at 0, 0, 0. And that's it. We have our start, spinner, limbo, axe, and end, like this. And we can see it's the end because there is this separation in the material. Back to the block end. So let's go. Make sure you are on the block end, not the block start. They are very similar right now. We are going to let me see, move the floor mesh up. Yes, I remember this. We're going to move the floor a little. So where is it? It's this one here. See that floor? So the only mesh there is in the block. We're going to set it to 0. Why? Well, just to create a small separation like this. Visually, the user will understand that this is the limit. It will be clear that that there is a limit right here. The ball won't jump on it. It won't be a bump. It will just go through it, like if it was like a low poly grass. The ball will be slightly inside of it. It's just a detail. Now we want to make our end a bit more appealing, like a reward, and it's going to be the hamburger. And the hamburger is going to be already in the public folder. So we're going to load it. You can try to do that by yourself. Add the hamburger right here and add some physics to it. Let's go. We're going to import use GLTF. So import, we have React 3 drain. No, not yet. So use GLTF, you know this one, from React 3 Dray. Okay, great. This one will enable loading of the model. In the block end, make sure you're inside the right block. Always make sure you're inside the right block. We're going to load the model. So hamburger like this equal use GLTF like that. And we're going to load the hamburger, hamburger.glb. And I'm going to put a point slash here to make sure that it works all the time. Okay, I think it's nice. Next, we're going to add it. So that's why we are using groups. We're going to do primitive object, so it's the usual hamburger, not just the hamburger, it has to be the scene, which is a group with the meshes inside of it. And check that, this is our hamburger. Big enough? Too big, obviously. Scale it down a little. So we're going to put a scale, not a scam, a scale. Calm down to 0.2, like that. I think we're going to make it slightly higher. And we're going to add physics. But yeah, since we're going to add physics, don't move it in the mesh, move it on the rigid body. We already have the rigid body in this file, so rigid body, like that. It's not going to move, so we're going to add a type to fixed, like this. And we get this, and it's already good enough. Next, it's good enough, but if we bump in there, obviously the user will think it's a bit weird. So we're going to, we can use the cylinder. Okay, actually I would have used a cylinder for for myself, but let's use instead the hue because the hue is cool. Like this, give it a reload, colliders hue, and we get this. It's funny, the color is kind of the color of the hamburger. I wonder if it's on purpose. So yeah, this one is super accurate, way too accurate, but anyway, let's move forward. We're going to put a restitution and a friction on it. So restitution equal, we're going to set it to 0.2 and friction to 0. I think it's the same as the obstacle. It's not that important. I mean, when the player reaches this part here, the level is already finished. I did a mistake, I'm quite sure. Oh, obstacle, because I was talking about obstacle. The friction to 0. Okay, next, move it up with the position, and I like to put the position after setting the colliders. Yeah, so position equal, and we're going to send 0, 0.25, 0, so that it's slightly higher, like that. Okay, nice. If you get some errors, just give it a reload and they're all gone. We want to activate the shadows on the hamburger. Since the hamburger scene only contains meshes, we can use a for each, all right? Because if you do it right here, like cast shadow, see that? It's not going to work because when you set it there, it's only on a group that contains meshes, but you need to add it to the meshes. So we're going to, there are multiple ways of doing that. We're going to do a for each on the children because there is only 4 direct children to that group. So hamburger scene, that's the group. Children, so that's just an array. For each, so that we loop on them. There are many ways to do a loop, and we get something like that. So this function will be applied on each child of the scene. We can retrieve the child, we're going to call it mesh, because I know there is only meshes in there. If you are using your own model, make sure that you have only meshes. You can also traverse it if you have a more complex structure. And I'm going to do mesh cast shadow equal true, like that. And now it's casting shadow. We are not going to receive shadow on the hamburger because maybe remember when you receive shadow on the hamburger, you get a weird bird like shadow acne on the top because it's a round shape and it's casting shadow on itself. And actually we don't really care about receiving shadow on the hamburger, so let's not activate it. We could create a lot more traps, but we're going to use those. That's already good enough and move forward. So for now we are creating the, yeah, by the way, this you can write it in just one line of code, but I like to keep it clear and easy to understand. We're going to do the blocks shuffling. Like right now we just put them manually. So in there we just put them manually. We want to create a random set of blocks according to an amount that we decide. Like we want 5 blocks and we will create those five blocks and take them randomly, but also position them where they are supposed to be. We don't want to position them manually. So let's start with the start block. We're going to get rid of all the others. So we just start with like this. So we have only a start block and we are going to set it at the 0. Okay, remember what I said earlier, this will be the 0. It's great to have coordinates that make sense. The player will start at 0, so that, I don't know, if you want to know how far the user went from the start, you can just test the vector position of the player, and its length will be how far he went from the beginning. It just makes sense, but that's not that important. And next we're going to create the trap blocks and then the end block. So for now we're going to focus on the traps block. We're going to create an array of blocks randomly chosen from the 3 types of blocks we currently have. That's the idea. We're going to decide on how many blocks we want through this count variable. Later we are going to do something else with the count, something a bit better. But for now it's just a variable. Next we're going to decide which blocks we want to be available. And for us, it's block spinner, block axe, and block limbo. I'm just enumerating the various blocks we have access to. If at some point I'm like, the limbo block is too hard or it's bugged, I can just remove it like that. So that's cool. If we were to provide our component to other developers, so in the case I'm like, okay, I created a game, I want other people to have fun with it and maybe just use the level part or use the player parts or whatever. So if you want to provide your code, so your components to other developers, you need to make your components more developer friendly. Like right now, if they want to change the blocks available, they will have to go inside the component, which is a bit messy. So we're going to change that by using props for those 2 values here. Another developer will be able to instantiate the level and decide I want, I don't know, like 20 traps, okay? And I want to have only spinners. That's cool. That's the way of coding and helping other and sharing our code. And we can do that quite easily. So in there, we're going to destructure the props directly. So I'm going to put it like, oh, come on, like this. What's happening? Okay, like this. Count is going to be set to 5 and types is going to be the same array. We are just doing the same thing. See, there is count and types, and we can get rid of this one here. It's the exact same thing for now, but those are now available as props. If you log count, since we don't provide a prop here, the count will be 5. And if I test types, well, you guessed it, we get the three function components, the block spinner, the axe, and the limbo. Okay, great. Next, yeah, by the way, this is totally optional, but it's great to create good components that other people can use. If they want to change it, they can do count equal 10 and then decides on the don't do what I'm doing right here, but you will see that I'm going to have an issue. They can decide what types of block they want, and they can say, okay, I want just block spinner. But wait, there is an issue right now. This code won't work. Why? I can give it a save. It's not working. You can do it with me, or you can just watch my screen because I'm going to remove those at some point. It's not working because the block spinner in the experience is not available. So how should they provide those? Well, it's quite easy. We're going to make those components, so the block axe, block limbo, etc., available outside. And we're going to export them. And to export them, we just need to add export right here. Not export default, okay? Because the level is exported as default, so that's how we retrieve the level. But those one, we will need to import them in a very specific manner. So we're going to do export block spinner, export limbo, export axe. So we are exporting every component, every trap, every blocks. Nice. But the level is exported by default. You can do that. You can have one that is exported by default and the other one that are exported using their names. But in that case, I prefer to have every export as non-default. So we're going to remove this one here. So on the level, you remove this one here. And I'm going to get rid of the logs, by the way. Okay, so everything is being exported as level, block axe, etc. But our code is now broken. Why? Well, because in the experience, we are importing it like if it was the default one. So we need to update this one, and to export a very specific component, it's just like we import from Dre, from Rapier, etc. We just write it like this. It's a way of destructuring, actually. Okay, nice. Next, if we want, don't do it, but I can show you. If you want the block spinner, well, you can just import the block spinner, and this code will now work, meaning that once we are done with this part here, it will generate 10 block spinners, just like that. But I'm going to remove those like this and like this. Okay, it was just an example. Later, actually, we're going to use those props, but for now, let's just do that for other developers that will work on the project and use our work. Okay, great. Make sure that you have everything like me. The level is imported properly. We have no props in the level. Back to the level, we set the count to 5 and we use all the types, okay? Block spinner, block axe, and block limbo. We're going to use those props. We're going to use memo, okay? To generate that array only once, and later it will be an opportunity to regenerate that array where if the count changes, if the type changes, and if we restart the game also. So let's go. We're going to import use memo from React right here. So use memo there. Next, we are going to call use memo, so it's inside a level. See, the code of level is getting quite big. That's when I prefer to have multiple files, but it still makes sense. Just make sure that you write the code at the right position. Use memo is returning something. Okay, it will return a random set of traps. So we're going to save those in the blocks variable. Then we call use memo like this. And to use memo, we need to send a function. Okay, this function will return the blocks. And then we need to provide the dependencies array. If any of the values the variables we put there changes, useMemo will be called again with and send a new set of blocks. And for us, we need a new set of blocks if the count changes and if the types changes. Okay, nice. Don't save yet because we are not returning anything from useMemo. You can add some line breaks. In there, I'm going to create a new blocks. It's not the same. I mean, it will be the same at the end, but I'm just creating a blocks and returning it. I know it's the same name, but don't worry, there is no conflict. This one only exists in the useMemo, and it will be returned, and we will retrieve it there. So it makes sense to use the same name. You create a blocks array, you return it, you save it in a blocks array. You can use different names if you want, but I like to use the same name usually. Next, let me see. We are going to log it because we want to see what we have inside of this one. So console log blocks. And we're going to code a traditional for loop in order to fill that array, because right now we're just saying an empty array. I'm going to do for let I equals 0. We start at 0. I less than count, so that I don't know if the count is 5, it's going to be 0, 1, 2, 3, 4. So it's going to do it 5 times. And I plus plus, like this. And I can give you a quick console log I. And we get 0, 1, 2, 3, 4. Okay, it's working, nice. In there, we're going to first take the first type, which is the block spinner, just to make sure that it's working. So const type equal types 0. We just take the first one for now. Later it's going to be random, but let's start baby steps. Push type, so we push that type to the blocks, and at the end we get 5 what? 5 block spinner. Nice, it's working. We are filling the array with just the first type. Okay, great. We can write this code in a much shorter way. I know, especially for React experts that love to put a lot of instruction in just one line, but I want it to be easy to understand. In order to have a random value, well, check that we have 3 values here. To access those, we can put 0, 1, or 2. That's the idea. Sometimes 0, sometimes 2, sometimes 1. It has to be random. We can do that with the math random. So we are. I'm going to write math random, but math random, don't save yet, is going to return something from what? Well, from 0 to 1, and we want 1 or 2. I mean 0 or 1 or 2. So what I'm going to do is multiply by types length. Okay, this one is 3 because there is 3 elements in there. So right now we have something that goes from 0 to almost 3. So it can be some really random values. I can actually show it to you, like check my console. I will do math random, multiply by 3. See what I'm getting? Something like that. Okay? It's kind of working, but sometimes we get like 2.9, something like that. We just want 0, 1, or 2. Well, to do that, we're going to apply a math floor on it. Check that. I'm going to write it here. I'm going to clean it and write it right here. So math floor is going to round it below math floor of this. And check that. I get 1, 0, 2, 1, 1, 2, 0. And that's perfect. Those are indexes. So let's do that on this one here. I'm going to wrap this in a math floor. Watch my screen, make sure that you didn't do any mistakes in there. So we have the math floor going all the way inside the brackets, and math random multiplied by types dot length, so that if we have a different amount of blocks like this, it will still work. Okay, what do we get at the end? Let's see. We get block spinner, block spinner, block spinner. That's unlucky. Block limbo and axe. We can try again. Block limbo, block spinner, block axe, axe, spinner. So it's working. Nice. We can remove the console log. It was just to make sure that it was working like this. And next we're going to use them. Let me see. Yeah, that's it. We're going, I don't know why I put the whole first part. Then we're going to add them here, and we're going to use a map, like a classic map. We've done that multiple times. So the name of the variable is blocks. It's an array, so we can map on it. And map, we need to send a function like this. This function will be applied to each one of the blocks and return something. So we can retrieve the block like this. I'm using Pascal case because those are those blocks here. It's not like a primitive component. It's not the declarative way. I'm trying to use my component, so I put in Pascal case. So it's mapping on the blocks, and I'm retrieving each block. And what I want to do, I just want to return that block. So in there, I'm just going to return it like that. Okay, I'm just mapping on them and returning them. I'm going to add the same line breaks to follow the lesson. What do we get? We get this. Not bad, not bad. We have some work to do, but it's not bad. When creating a list, we need to provide a key attribute, and that's the error we get right here. It's the usual thing. When you create a list, so what React call list, it's when you loop using a map or something like that, you need to provide keys. Unfortunately, we don't have IDs for this one, but we don't really care about that. We can just use the index. So let's go. We're going to retrieve the index from the function we send to the map by doing index. Make sure you have the right position. Those are the arguments of the function. And in there, we're going to provide the key and set it to index, just to give to React a key, so that we get rid of that error. Okay, as you can see, we get a bunch of random obstacles, and it looks good. Nice. Obviously, they are not well positioned. To position them, we're going to change their positions, because remember, those are the same blocks as before. We can change the position, just like we did for the block start, but we set it to 0 in there. So make sure it's at the right position. This component here, we can set the position prop. So position equal, we send an array, XYZ as always, X0, we don't care, Y0, we don't care, but the Z, we're going to use the index, because remember that index here, it's just the index of the array, so it's going to be 0, 1, 2, 3, 4, because we have 5 values, so it stops at 4, and we can use that. So if I just put index, what do we get? We get something like that. So there is two issues. First, they are too close. We need to multiply them by 4, because each block is a size of 4. Remember here, a size of 4. So that's better, but unfortunately they are going the wrong way. Actually, it's up to you. Is it really the wrong way? I like to see the forward as being negative z. A lot of software are seeing the same way, but forward could have been positive z. But we're going to fix that and set it to negative z by just doing a minus in front of this one here. So in front of the index, you just put minus and check that out. Nice, it's working. We have one other issue. The first trap is on the start block. So to fix that, this index here, we're going to put it in parentheses and just add 1, so that it's not 0, 1, 2, 3, 4. It's going to be 1, 2, 3, 4, 5. So plus 1. And check that, give it a reload as always, and it's working. So nice. And if you change, I don't know, like this value here, you put 10 because you want 10 traps, and you get 10 traps. That's so cool. If you want 2 traps, you get 2 traps, and the hot module replacement is taking care of destroying everything. I mean, React Prefiber, etc. are taking care of destroying everything without reloading, thanks to the hot module replacement. That's so cool. Let's put back 5. I want to really follow the lesson. All we need to do is add the end block. So let's go. I will be lazy and duplicate the block start and put it at the end. And I'm going to call this one end. As for the value, well, if you put 0, it's going to be there. We want it to be there. I can provide you the formula. It's going to be minus, because remember, it's minus z. It's going to be count, which is the number of traps, plus 1, okay, because we start plus 1. Multiplied by 4, because it's 4 units per block, and it's there, okay? Sometimes you don't need to re-understand the formula. You see that it's not at the right position. Okay, I guess I need to use count. Okay, it was too close. Like I probably did that. Like first I use count multiplied by 4. I'm like, where is it? Oh fuck, wrong way. So I put minus count multiplied by 4. Where is it? Okay, not bad, but there is a block on it. So maybe count plus 1. Yep, good. That's the way I do it. I'm not good at math. I just tried numbers until it works. So the shadows aren't working at the end of the level. Check that. We have a shadow here. We have a shadow here, and then no shadow. It's an issue, but we're going to fix that later. The bounds, yeah, we need to add walls, okay? We're almost done with the level. That was quite fast, but yeah, we are almost done. But we need some walls on the sides to delineate the level and make sure that the player can't fall too easily. And also one at the end. We're not going to put one at the beginning, okay? Just at the end. First, we're going to put those in a different component just in order to separate into multiple components. So function bounce like this, and we're going to return a fragment already because we will have a bunch of things inside this one. Next, we're going to instantiate it, add it to the our code. So it's going to be bounce in the level. Bounce, yeah, that's it. So nothing in there because for now it's just a fragment. We want to be able to control the length of the bounce from an attribute, okay? Because the length of the level is defined by the amount of traps we want. So this one here, and we want to send that value there in order to calculate the right size for the walls. We're going to add a prop. It's going to be length, and we're going to set it as a default value of 1 because why not set a default value. Next, in there, in the bounce, we're going to send another value. So it's going to be length, and it's going to be count plus 2. Okay, because there is count is the amount of traps. Maybe we should have named it like trap counts, but I like to keep it short. So counts plus 2 because there are also the start and the end blocks. So let's go. We have the value here. We can actually log it. It should be something like 7 if I'm right. Yeah, 7 because there is in total 7 blocks, 5 trap blocks and 2 the start block and the end block. Let's start with the right wall. So I'm talking about the one right here. Okay, this wall here. We want it to be thick, 0.3 thick and 1.5 high, and you can try to do that yourself. So let's go try to create that wall. I'm going to draw it quickly. It's going to go from there to the end, 1.5 high like this, and 0.3 thick. Okay, so this one is going to be 0.3, and this one is going to be 1.5. Try to do that. I'm going to remove this one because it's messing with my code a bit too much, but that's the idea. And all the way to the end using that length here. And let's do it together. I'm going to remove the console log. We don't need this one. I'm going to add the mesh. As always, we don't care about physics at the beginning. Since we're going to use the box, the material and the geometry we created outside of the components, we can auto close it. For the position, let's see, I'm just going to use those values that I already calculated. It's going to be 2.15, 0.75, and this one is a bit silly. It was probably the part where it's a bit hard to calculate it. Length multiplied by 2 plus 2. I have no idea why. I just put some values until it was working. We will see what we get. Geometry, we get, this is not an interesting part, so we don't really care about this formula. For the geometry, we use the usual box geometry because remember my drawing is just a box. For the material, we use the final material that we haven't used yet, which is the wall material. And for the scale, where we're going to do, so 0.3 is the thickness, so it's on the X, 1.5 on the Y, makes sense for now. And for the depth of it, it's going to be 4 multiplied by length because each trap is 4 units long, and we get that. Nice. Next, we wanted to cast shadow, and only cast shadow because there is nothing there that will cast shadow on it. We don't really care about that. We just wanted to cast shadow, and as you can see, I told you earlier, it's the shadow stops over there. We're going to fix that later. Next, we can do the left wall. So we're going to be lazy and duplicate the whole mesh. And we're going to invert the X only, like that, okay? And we get the other wall. We're going to change the cast shadow and receive shadow. This one here doesn't need to cast shadow because the light is somewhere over there, and there is nothing over there to be to have the shadow of the wall being casted on it. So we're going to remove the cast shadow, but this one might get shadow like from the obstacle. See right here, wait a moment. See, the shadow is missing right here. So we need to set the receive shadow on this one, and now it's receiving the shadow. So convenient, I love it. We need to add a wall at the end of the level, okay, right there, so that the user, when he finishes the level, it doesn't fall. So let's add this last one here. I'm going to be lazy again and duplicate this one. Okay, so there is 3 meshes in there. And for the values, let's be lazy again and just use those coordinates that I figured out. So 0.75 minus this one out of nowhere. So length multiplied by 4 plus 2. No, actually, it makes sense. So it's going to be weird because the size is not right yet. We're going to put 4, which is the width of the blocks. 1.5 for the 8, it's the same, and the thickness for this time is on the Z. So like this, and we get something like that. And it's working very nicely. You could have changed like the size, maybe make sure that it goes a bit further away. We don't really care about that. It's just fine. Because it's at the end and the player won't be able to see the level like we see it right now. Okay, let me just check. Receive shadow, yes, why not? Cast shadow wouldn't make sense because the light is near us. So yeah, it's fine like this. We just wanted to receive shadows. Next, we are going to add rigid bodies, and instead of creating one rigid body for each one, we are going to create a global rigid body all around them. So rigid body, like this. We're going to put the 3 meshes inside this rigid body, and we're going to set the type to fixed because we don't want them to move. Type fixed. And if you remember from the physics lesson, when there is multiple mesh in a rigid body, React 3 Rapier, we create one collider for each one of those meshes, and by default it's cuboid, and cuboid are just fine. You can see the wireframe of the cuboid created there, and it's perfect. We can change the restitution and the friction. I think it's the same as for the obstacle. It's for when the ball will bump into the walls. We want them to bump a little, but to not rub too much. So we're going to set the friction to 0. So restitution, we set it to 0.2, and friction, we set it to 0, like that. Okay, we can't see the result of that yet because we don't have the ball of the player, but it will make sense once you see it running. We forgot one important feature, it's the floor, because right now if we add the player, it will just fall through the floor. And this one, there is already floors. We could have maybe optimized this part here, like if we have, I don't know, like 10 traps, we will get 10 geometries. We are fine with that. We won't have that many geometries in the end. Anyway, performances will be just fine. But if you want, you can optimize the part here to have only one box for the floor. So you remove those from the blocks and you add it in the bounds. We're not going to do that here. Instead, we're just going to create a collider because we still need to add a collider, and we're going to use a cuboid collider. So let's go import cuboid collider from React 3 Rapier. Cuboid collider, like that, don't forget the comma. And then we're going to add it to the bounds rigid body. So where is it? It's at the end, like there. And we're going to add it, yeah, why not, at the end of the rigid body. So make sure you are in the bounds component in the rigid body, so inside of it, and at the end, right here. So I'm adding the cuboid collider. I can just put some default arguments to make sure that it's working. So args equal, oops, it's gonna be 1, 1, 1, like that. Okay, let's test. Okay, it's working. That's my floor. Okay, so now we need to move it and stretch it. We're going to set different args. So it's going to be 2, 0.1, 2 multiplied by length. Okay, let me see. Give it a reload. Yeah, it's this one here. And next we need to move it to the end, further away in the level. So we're going to do that with the position. And again, those are just formulas that I figure out, not very interesting, just to use my formulas. So it's going to be 0 minus 0.1, and the last one on the Z is going to be minus the length multiplied by 2 plus 2, which makes sense actually. Give it a reload, and that's perfect. See, it's right here going all the way to the end from here to here, so that the player won't be able to fall. We will still be able to fall when going back, which will be useful if we want to test if the player will be able to maybe jump on an obstacle and then jump there in the void. So we need to handle this. And we didn't put a wall here so that we can test it just by going back. It's going to be convenient. We can set the restitution on the collider itself because, yeah, we provided it ourselves, so we need to set it ourselves. And we set the same thing. So, no, actually, it's not the same thing. We set the restitution to 0.2 so that it bounces a little, but check that. We set the friction to 1. And that's a bit weird, no? Why would the friction be 1? Well, because when the ball will rotate on the floor, see that ball here? Yeah, it's kind of a ball. When we make the ball, when we want to make the ball move, we will do a rotation. We will not just do a rotation, but that's one of the things we will do, a rotation. If the floor has a friction of 0 and the ball has a friction of 0, it will just rotate like this because it will just slide on the floor like that, just like in cartoon when they are running super fast. It will just do that. If we add friction there, then by rotating the ball will move forward. So we need a lot of friction there. That's the reason. Okay, back to our code. So set the friction to 1. Nice. And we are done with the level. We can start with the player. And see, we did quite a big chunk of the lesson. You are doing good progress. So the player, we want to play as a marble. That's what I call a marble. It's just a ball, but I like to call it a marble. You know, as a kid, we played with a marble. That's we move around with the keyboard, and we are going to handle the keyboard much later. First, let's create a different component because it makes sense to separate the player in a different component. The code will be quite big because most of the logic of the game will be in the player component. So player.js, in there we export by default. We won't have anything else than this player. So default function player, return, and we can already add a fragment, and we have not that many code in there. It will be mostly in the logic inside the function. In the experience, so make sure you save the player.js. Back to experience, we're going to import it. So it's going to be import player from player like this, and we can add it there, and it has to be inside the physics because that ball will have physics on it. Okay, great. Back to the player.js. So make sure you have added the player, so you import it as the default import, and you add it to the physics right here. After the player, the level doesn't matter. You can put it anywhere in the physics. Back to the player.js file. For the actual marble, we're going to create a mesh with a icosahedron geometry. You will see what's that. So let's go. We're going to create the mesh. I think we only have a rigid body at the end, so we can get rid of the fragment, but we will do that later once we are sure. Icosahedron geometry. What's that? You will see. And we see why we use this one also. 0.31 and like this. And check that out. This is a icosahedron geometry. What's the difference with the ball? Well, this one has just a bunch of triangles that have the same size all around it. So if you want to place a texture like, I don't know, the earth texture on it or something like that, it won't work well. But if you just want a round ball and have the triangles having near the same size, you should use this one, icosahedron geometry. And we're going to change the material. So mesh standard material. You will see the geometry more clearly a bit after. Color, I'm going to use the medium purple that I really like. Medium purple. I mean, it's the color of JS Journey. So let's use this one here. Makes sense. We wanted to cast shadow. So let's go. Cast shadow, and we don't put the receive shadow. That might sound weird, but we don't want it to receive shadow so that when we move in the shade right here, we can still see the ball clearly. That's the reason why I'm not using the receive shadow on it. It's just for the gameplay, so that we always see our ball. It's not very realistic, but it's fine. We want the player to be able to see that rotation. When that ball will start spinning, we want the user, the player, to see that rotation. And right now it's so smooth, we can't see much. To fix that, we can simply add flat shading. And check that, give it a reload. It looks like that. And now you can see the shape I was talking about. See? It looks like this. And we will be able to see those faces rotate, so it's much better for the gameplay. Next, we need to add physics. So we're going to import a rigid body because we don't have it in this file. So rigid body, like that, from React 3 Rapier, like that. We're going to wrap our mesh in it. So it's going to be like that, like this. And what do we get by just setting this? It's working. Nice, so convenient. I love it. Obviously, we have some fixes to do, but it's working. Since it's the only one we are returning inside from this component, we can remove those fragments. I'm going to remove those. They don't hurt anyone, but let's keep our code as simple as possible. Next, we're going to put the position a bit higher because by default it's in the floor. And that's why we get it's pushed up quickly. So that's why we see this little hiccup like that. So we're going to move it up a little. Position equal. We're going to send XYZ, so 0, 1, 0. So it's slightly above the floor. So let's start like that. Makes sense. Next, we're going to change the colliders because we have trouble making such a weird, such a cuboid shape. I mean, it can be funny, like to rotate a cuboid, but let's make a ball instead. So on the rigid body, colliders equal ball, like that. Give it a reload, and now it makes more sense in it. We're going to set the restitution to 0.2. Restitution equal 0.2 like this, and the friction to 1 for the same reason as I explained for the floor. We want it to bounce a little, so if you give it a reload, see, it does a quick bounce, like not too much, because we want it to stick on the floor fast, but we want it to be a bit realistic. If we fall from high, we want a small bump, but very small bump, because we need it to touch the floor as much as possible, because we are going to make it rotate. As I explained there, the ball will rotate, and we added a high friction between, I mean it's 1, so top friction between the ball and the floor, so that they rub, and when rotating the ball it will move forward. Actually there is a trick also with that, but I'm going to explain in due time. Alright, restitution 0.2, friction 1. Next, what do we have? The controls already, nice. We will only focus on desktop. Yeah, by the way, the lesson is big. Let's just focus on desktop, and also because it's hard to show you like on mobile, maybe I can have another camera or something like that. So it's so hard. We're going to focus on the desktop only and use the keyboard. Feel free to add more support. You can have a lot of fun. Imagine that you're controlling using, you know, the device orientation. That can be super funny. You can use a controller. It's not that complicated to add a controller support. You know, a controller like a manette, we said in French, like a PS4 controller or whatever. Anyway, we're going to focus on desktop and a keyboard. So we want the player to be able to use both WASD and the arrow keys, all right? We want it to be able to use this part here, like for real gamers, they know that, and this part here. We have a lot to talk about with keyboards. And we want to make the marble jump when we press the space bar. Okay, when we press this, the marble is going to jump a little so that we can go above some obstacles. Keyboard controls. This one saved me. This one saved me. In React, adding keyboard controls to game used to be tedious. There was many solutions, and I've implemented like multiple solutions. I was thinking, man, I can't explain that to the students. It's going to be too complicated. But there is a helper. I haven't said that I haven't said that for a while. There is a helper for that, thanks to Dre, and they added it quite recently, and this one is it's a savior. And it's the keyboard controls. We need to import keyboard controls and wrap every component that has to be aware of which keys are being pressed. So if we want to use keyboard controls for the player, where we can just wrap, I don't know, like the player here in keyboard controls. But we're going to have a lot of things, and we are going to have an interface. And that interface will use the keyboard control. You will see why later. Meaning that we need the keyboard controls to be at a higher level. We need it to be, let me show you in the index, you can open it with me. We need it to be even above the canvas, because this interface we are going to create is not going to be part of React Fiber. So it's not going to be part of the canvas. We're going to add it over there. And this interface needs to be aware of what keys are being pressed. It will make sense once we will create it. So we need to create the keyboard controls above everything. So let's go. In index.js, we're going to import it. It's going to be, we don't have Dre yet. So import keyboard controls from React 3 Dre. Nice. And we're going to wrap everything. So follow me, don't save yet. So keyboard controls like that. And you wrap, for now we just have the canvas, but later we will have something else in there. And in that opening tag, we're going to add some line breaks and put a map. okay? And to that map, we send an array. So what's that map exactly? So for now, there is nothing in it and it's working, so that's great. Default settings are working. That map array, in there, we need to provide each key that we want to observe as an object with a name and a list of keys that should trigger the change as another array. Oof, that's too much. We are just going to write the forward key and it will make sense. So in that array, we need to specify every keys that should do something, in other words. And we're going to start with the forward key. And each key needs to be an object, like that. You decide on a name. So for me, it's going to be forward. Okay, it can be up or whatever. And then we decide what keys on the keyboard should trigger this forward. And you provide keys because you can have multiple keys, which is perfect for us. And we send an array because there are multiple. And we set it to arrow up. And forward is going to check your keyboard. Is it W? I'm going to write key W. And this one is super important, especially for me. I'm going to explain why right after. So this one should work. You can press it. It's not going to do anything for now. We need to then use those values. And we are going to do the same for the backward, leftward, rightward, and jump. So we're going to add a comma here, duplicate it a bunch of times, and remove the comma here. So forward, okay, backward like this. It's arrow down, and this one is going to be key S. Leftward is going to be arrow left, and the key is going to be key A. Rightward, I forgot the word. Be careful with the left. It's leftward. The keys are going to be arrow right. Okay, makes sense. And key D. Check your keyboard. Maybe. And finally, the last one is jump. And for the jump, we just want to use the space bar. I think this one is more than enough. Okay, we save. We are using key names like key W and not W. If you do this, for most of you, this would have worked. It would have worked. Why? Well, because check your keyboard, key W, W sounds like the same thing. But check that out. I'm not sure you're going to see it. Let me check the focus. Yeah, maybe it worked. See the letters right here? I will tell you in case it's not working. Those are not QWERTY. See where my finger is right now? Those are not QWERTY. Those are AZERTY. Those are French keyboards. It's trash. I hate those. I keep using those because sometimes I need to switch between my real life students. To use the keyboards of my real students. And when you switch between keyboards, it's a mess. But here's the thing. There are multiple types of keyboards, not just French keyboards. Most of them are QWERTY, so it's fine, but some are not. And when you use key W, it means this one here, regardless of the type of keyboard. If you say W, it's the W letter, meaning that if you put W like this, French with a French keyboard will have to press this key to move forward. It's a mess. He wants to press this key. So please use the key W, key something, not just the character. This is the position on the keyboard. This is the character. And the keyboard controls handle both. So it's up to you to provide this one here. For the arrow, don't worry, it's the same for everyone. I'm quite sure of it. All right, make it roll. We're going to make our ball roll, so our marble roll. So back to the player.js, and see, it was super convenient to implement those keys. Now we need to get this information in order to move the player or whatever we want to do. Since we are going to apply forces whenever the corresponding keys are being pressed, we need to do it in a use frame, okay? On each frame, we will test if the key is being pressed and move the ball accordingly. So let's go in player.js, make sure you're in the right file. We're going to import use frame so that we can trigger instructions on each frame. We've done that many times. So React 3, it's fiber, like this. And in there, so that's what we have for now, we're going to call use frame and provide a function that will do a bunch of instruction on each frame. This one is going to be to get quite big, by the way. Okay. Now we need to know, before rotating the ball, we need to know which keys are being pressed. We're going to import, check that, use keyboard controls from Dre. Okay, so in there we imported keyboard controls in Pascal case, and in there we are importing a hook, so it's use keyboard controls, and those are linked together. Great. Next, this hook will return an array of two things that we're going to destructure. Obviously, if it's an array, usually it's for destructuring. A function to subscribe to key change. So using this function, we'll be able to subscribe to the event like this key has changed, and we will be able to do whatever we want. And a function to get the current state of the keys. Like we call this function and it will tell us this key is pressed, this key is not pressed, this key is pressed, etc. So that's the idea. So we get everything that we need. So let's go. We're going to implement it. It's going to be const. We can destructure it already. Subscribe keys. I wrote it wrong, that's for sure. Subscribe, yeah, more like this. Subscribe keys. I hate writing that word. And the other one is going to be get keys. Subscribe, yeah. Anyway, we're going to call use keyboard controls that we just imported, and check that we just get those two things here, which are just two functions. See that? First one, second one. I'm going to create two console log. It's a bit weird to have both of them on the same line. Okay, so this one here and this one, there is a re-render. That's why we have multiple ones. So this one here is to subscribe to key changes, and this one here is just to get the keys state, the current key states. It will make sense once we apply them. For now, we don't care about subscribing. It will be for the jump, but in useFrame, we need to know if the forward key is being pressed. If it's pressed, we are going to make the ball roll. So let's go. We're going to do const keys equal get keys. So we just call the get keys. It's a getter, okay? It's to retrieve something. And we're going to log it like that and check that. So we get it on each frame. Now press the arrow up key and see the forward. It's switching to true when I press it. And if I press the Z, for me it's Z, for you it's W, it's doing that. So it's working. In there, we are aware of what is being pressed. That's so cool, so easy, so convenient. By the way, we can destructure it. So we are going to do that. We're going to only get the forward, the backward, the, not background, backward, left word and right word, and I'm just going to check that those are well written. Let me see, they are all false. And if I press upward, rightward, downward, yeah, okay, it seems just fine. Cool, they're all changes as they should. Next, in order to make the marble move, we are going to apply both a roll force, so that's the one I was talking about. We're going to do that, so we're going to make it roll like this. Let me actually remove this. I'm going to change the color. So the roll is going to be like this. Okay, we are going to make it roll or whatever. You can do it. It's just going to roll. We are just going to apply a torque, which is a rotation, and we are also going to push it. Why? Well, because if the ball is above the floor, there is no friction with the floor, and it will rotate freely like this. And it will feel bad for the player. Just check the various platform games you've been playing, test them again. You will see that most of those games you still have a slight control when you are in the air. Not as much as when you are on the floor. If you want to go left on the floor, it goes left. But when you are in the air, you can still slightly move on the left or on the right. I said left anyway. You can still move on the sides, but not as much. And that's exactly what we're going to do. Since the ball is in the air, like, I don't know, he jumped or bumped into something, we won't be able to move as easily, but still, thanks to this translation, so this force, we will still have some control. That's the idea. Okay, nice. To make the marble roll, we are going to use the apply torque impulse. Remember that this is just a rigid body, like a classic dynamic rigid body. So we need to apply the classic force method, like we're going to apply a torque or an impulse. That's the idea. Let's go first. Since we are going to apply it on the rigid body, we need a reference to that rigid body. So import use ref from React. Like that. Next, we're going to create that reference. I'm going to call it just body. It doesn't have to be like player, ball, etc., because that's the only reference we will have to something in there. So just body is fine. We're going to associate it with our rigid body. We're going to call it body. I mean, we're going to call body. Nice. Next, in there, right here, we need to handle those forces. It's not going to be that complicated, you will see. We're going to do both an impulse and a torque, and we're going to prepare those that we will send later to apply torque. What was the name? It was they apply torque impulse and apply impulse. We're preparing the values. So for the impulse, it's going to be x0, y0, and z0. For the torque, is going to be the same. Actually, I can just copy and paste like that because it's a Euler. Why are we preparing them before? Well, because sometimes you can press two keys at the same time, meaning that you will still apply one impulse, but it will both impact the x. So if you press like forward and rightward, it will both apply on the x and on the z. That's the idea. You can have multiple forces, but it has to be on one impulse and one torque. You don't want to apply two impulses if there is two keys being pressed. Otherwise, it would be too strong. So instead, we just provide one impulse and one torque, and we play with those values according to what the player is doing with the keyboard. And to start with, we are going to use them directly on each frame. They are set to 0, so nothing should move for now. So body current, apply impulse like this, and we send the impulse, which is at 0. And body apply torque, I think it's torque impulse. Yeah, that's it, torque impulse, like that. And we send the torque. So make sure you have the same as me. So apply impulse, we send this impulse, and apply torque, apply torque impulse, we send this torque here. Give it a save, give it a reload, nothing is moving. But we can see if it's working. Check the impulse here. I'm going to provide a very, very small value, 0.001, and check that it's moving. Yay, the ball is moving. So not from the keyboard, I haven't touched anything, but we just on each frame provide a small impulse on the right, and if I put minus 0.1, it's going to move on the other side. Okay, let's put back 0 for now, and see how we can change those when we press the keys. By the way, before applying forces, we need to handle the variation in the frame rate. We're not doing the mistake and then fixing the mistake. We're going to fix that already. Meaning that right now, see that the apply impulse, for me, it's going to happen 60 times per second because my device is running at 60 frames per second. If you are using a gaming PC or something like that, it's probably much higher. Meaning that the apply impulse will be applied much more for you. Okay? So we need to make sure that everybody gets the same result, and we are going to do the usual technique by getting the delta time and using that delta time on the forces that we apply. To get the delta time, we just retrieve the states. We're going to use it later. What we need is actually the second argument, which is the delta. Okay, remember that one? I can log it quickly. See, it's how much time was spent since the last frame. For me, it's this value here. If you have a faster computer with a high frame rate, the value will be much smaller. So you will apply those forces more often, but it will be a smaller force. That's the idea. We've been doing that quite a lot. Okay, and to fix that, we're going to we're going to create variables. True. We're going to do impulse strength. Usually you don't have that many variables, but I want the code to make sense. So that's why I'm creating that many variables. 1 multiplied by delta. Why 1? Well, because later we're going to change this one in order to reduce the impulse or the torque. Okay, so for now, just put 1, it's a placeholder. And torque strength is going to be 1 multiplied by delta 2. Okay, we're going to change the 1 later. If forward is true, meaning that the player is pressing arrow up or the W key, we are going to change first, we're going to change the impulse. So let's go, it's going to work, you will see. If forward is true, you don't need to put equal true, no need for that. We're going to do impulse.z, and it's going to be minus because forward is minus z, impulse strength, like that. Okay, so we are changing this impulse, it's a vector 3, so x, y, z, we are changing this one according to what's being pressed, and we multiply what we change here according to the impulse strength. That depends on the delta time, a lot. And then we send that to the impulse at the end with the apply impulse. Okay, we can test it. Check that. I'm going to press arrow up and check that. It's moving, yay. I'm going to press, for me it's a Z, for you it might be W, and it's moving forward. Nice, the game starts to work. That's the critical phase, yay. We can start having fun, and usually that's the moment where once we have all the controls, you will see we lose quite some time just by playing with your own game, which is perfect. The more you enjoy creating those kind of things, the more time you will spend on it, and you will get better at it and have fun, and that's a life goal. So we can make it roll, and to make it roll too, remember we are playing both an impulse and a torque. This one will be on the X. Wait, I can make another draw. I think I will do it, yeah, like that. I will put it there. So this is our floor. Why not? We don't really need the floor actually. This is our sphere. Please be rounder. Yeah, it will do the trick. This is the Z. All right. So when we want it to go at the end of the level, we do it on the Z. But for the torque, we want it to rotate like this. It's hard, we don't have a perspective. So like that, see? We want it to rotate, it's hard to say, but it's going to be on the, imagine that you have a spike going like this. We need to rotate around that spike. So it's going to be on the X. That's the reason we want it to rotate. Maybe I can show you with my hands. We want it to rotate like this toward the end, which is there. So it's like putting a spike through it and rotating like that. So it's going to be the X. If you're not sure, you just test it and hope for the best. And if it's not the right value, you just change it. I probably got this one wrong multiple times. And we do the same. So torque X minus equal. Yeah, it's minus. This one, I'm quite sure I got it wrong. Just test and see what happened. And check that. I'm going to remove the impulse just to make sure that it's working. And it's working. It's way too strong, but it's working. And now it's going crazy. I can't go left and right, but it's working. So cool. I'm going to put back the impulse. Yeah, so those are too strongs. I'm going to reduce the impulse. I told you we are going to change those. The impulse will be 0.6 and the torque will be 0.2. Okay. And now I have both of them applied here and I can move forward and see it doesn't move that fast. It got quite fast, but don't worry, we're going to add something later that will make it go slow anyway. So keep those values for now. At the end of the lesson, you can change those if you're not happy. You can try to add the rest of the keys. Okay, we did forward together. Maybe you can pause the video and try to do the other one yourself. You should comment everything and just focus on the impulse, then the torque, then the next one, the impulse and the torque. Anyway, let's do it together. So I'm going to duplicate this one. Oh, my ball just felt too bad. So rightward, I'm going to do forward, rightward, downward, leftward. I like this order. I didn't do it in there, but for me it's always forward, backward, downward, leftward, because it's like a clock. That's my way of always making things the same way. So rightward is going to be impulse X, and it's going to be plus equal this. Torque Z minus equal this. Okay, make sure you have the same as me. For the rightward, it's this. I'm going to duplicate this one. Next one is going to be backward. Impulse Z, yes, it's on the Z, makes sense. It's going to be plus equal because it's positive when going back. And torque X is going to be plus equal. It's actually the opposite of what we have here. It's the same, but it's the opposite. And let's be lazy and duplicate the rightward for the leftward. Might be a mistake. Let's see. I'm going to do impulse X minus and torque Z positive. Okay, make sure you have the same as me. I'm going to test it first because I probably did a mistake. Left, right, back, forward. Nice, it's working. Woohoo! And it's gone. Let's move forward. Maybe pause the video if I went a bit too fast. Yeah, we have a small issue. Check that. I give it just a little impulse. And it's rolling and rolling and rolling. Wow, it's rolling like forever. That's weird. Let's try like forward. See, it's rolling, 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 rolling. It's not too much of an issue. But the players sometimes they just want to stop. Like if they want to have fun and try to jump, like I don't know, they are trying to jump on the side wall like this, they will have to be precise. They will want to be able to stop. And for the gameplay, it's just better that at some point it stops. So right now it's always moving. That's not great for the gameplay. How can we do that? Well, the thing happening is that it's rolling, but there is nothing preventing it from rolling. So in terms of physics, without having like air frictions and things like that, and the material that are rubbing, etc., we don't have those in rectangle fiber by default. It will just keep rolling because it makes sense mathematically. But we have solutions. We can apply damping. And we can apply a damping for the translation and a damping for the rotation, meaning that the ball will, if the ball is rotating, at some point it will stop rotate. If the ball is moving, at some point it will stop moving. If it's in space, you should not use those, because if you send, you are in space, you just throw an object, it rotates, it moves forever. But on Earth, we should apply some damping because of air friction, etc. So let's go. We're going to apply those on the rigid body here, and I'm going to add some line breaks finally, like that, like that, like that. You don't have to do it, but let's do it on the rigid body. And we're going to apply the linear damping. So right after the friction, I like to keep this order. It's going to be 0.5, and right after the angular damping, it's going to be 0.5. I'm not sure of this exact value. Maybe it's going to multiply the current linear speed by 0.5, I guess. I'm not sure. Anyway, give it a try. I'm going to put a small impulse, and the ball will stop on its own. It takes time, but it stops. And that's why we actually kept a value quite high for the impulse strength and torque strength, because it will slow down with that damping. And now see, it got much funnier and easier to control, right? Okay, let's move forward. We're going to make it jump. We want the marble to jump when we press the spacebar. Okay, this one works a bit differently because we don't want to make it jump on each frame. By that I mean, if we put the jump in here, it means that if we press the spacebar and keep it pressed, it will jump on each frame, making it like go crazy up in the sky. So that's not the way of doing it. We want to make the ball jump only when the keyboard went from not pressed to pressed. That's the idea, okay? How do we do that? Well, we do that with this little guy here, the subscribe keys. That's the whole point of this one. This one gives you the current state. We call that a state. And this one will let you listen to changes on that state. And we will listen to the jump change. So convenient. I love it. We want the subscribe to that. Yeah, we want to do it only one time at the beginning. So we are going to use the classic use effect. So import use effect from React like this. We call it, let's say, somewhere over there. Yeah, before the use frame. Okay. So use effect, we provide a function. This function will be called only once because we set the dependency array to an empty array. It's the usual. In there, we're going to use the subscribe keys. Follow me. This one is a bit hard, but I think you will understand. We're going to send two functions to this one. So this one here, comma, this one here. Make sure you have the same code as me. Check that. One function, okay? And separated with the comma. Those are just functions that I send to subscribe keys. Next, in there, in the first function, I'm going to give you the name of this part here. We call that the selector. The selector is a way of saying, I want to listen to this. I want to listen to the jump. I want to listen to the forward. I want to listen to any change on the keys, okay? That's the point of this function. It's a bit weird because we send a function, but that's the point of this part here. And when a change appears, it happens, it will call this function here, okay? That's why it works like this, and we need to send two functions. So in there, we're going to tell that what we want to observe, and we're going to return it. We're going to do return state.jump. We just want to listen to the jump. Okay, that's the way of subscribing to something. If you want to listen to any change, I think it's something like that. Okay, we want to just listen to the jump. And since we are using an arrow function, we can remove, and there is only one instruction that returning something. I mean, it's a return, the only instruction is a return. We can, as usual, remove those, so the opening curly bracket, the return, and the closing curly bracket, and put everything in just one line. Okay, it looks like that, and it's convenient. Okay, but I wanted to show you that this is actually just a function, and it's what we call a selector. We just want to listen to the jump keys. It's a bit weird, but it makes sense, and it's optimized internally, and we will actually use that in a different context, you will see. So yeah, we call that a selector. Next, we want to do, well, to do some instructions, and we're going to start by doing a console log of the jump state. So in here, we can know the state by putting any argument. You can call it whatever you want. If you're sure that it's going to be jump, you can put jump. I'm going to call it value because it can be something else. If you listen to the forward, it's going to be the forward. So I would just call it value. And in there, I'm going to put jump and send the value to make sure that it's working. Okay, so if jump changes, this function should be called, and we should have the state of the jump. Try it. I'm going to press it now, and see, it worked. It went true, and then false when I released it. I'm going to press it, it stays true. I'm going to release it, it went to false. So convenient. It's not that complicated. There is just this selector thing, but you can just write it like that and use it, and it's working. Okay, nice. We want to make it jump only when it goes to true. We don't want to jump when we release it, because when you create games, it has to be super fast. When the user wants to jump, it's when he presses the key, not when he releases the key. So we are going to say if value, so equivalent of equal true. So if value, then we are going to say yes jump, like that. You can put whatever you want in the console log, and check that. I'm going to press it, yes jump. I still haven't released it. I release the jump, nothing happened because we are just testing that it's true. Okay, cool. We're going to put the jump in a different function so that it's a bit more convenient. So const jump equal like this. We just put it outside. We could have put the jump in there, but we will have some code, so it makes sense. And yeah, and don't forget to call it. So in there, I'm going to move the console log in the jump like this and call jump like that. Okay, no tricks. I just put the console log in a function, and I'm calling the function. Give it a try. I can jump. All good. Next, yeah, this one is good. To make it jump, well, actually, it's super easy. We do body current, and we've done that. You remember the cube? We clicked on it and we made it jump. We're going to do body current, apply impulse, and we need to provide a vector 3. So it's going to be x0. Y, we provide the value, I don't know, like 0.5, why not? And z, 0, because we wanted to just jump upward, like a straight upward. Apply impulse, okay, let's test, and it's working. Wasn't complicated, but there is a catch. What happened? Maybe you can find it. There is a gameplay issue right now. Did you find it? Check that. I can jump. I can jump even if I'm already in the air. Okay, that's an issue, because if you give it, I don't know, like quite a big impulse and jump, and fall in the hamburger, and then it's done. Okay, I wasn't far enough, but you get the idea. The gameplay is broken right now, so we need to fix that. So how are we going to do that? We're going to test how far the marble is from what's below. Okay, check that. We're going to test how far the marble is from below. I'm going to do a quick drawing again. So it's going to be, I'm going to create a floor like this. Yep, this is my floor. I'm going to keep some room on the right, so like this and like this. I'm going to put the marble here, so it's already in the air, and we are going to cast a ray, so from here downward, okay? And it will test where is the collision, okay? The ray is going to do that, and we're going to test the collision, this one here. And if the distance is too high, something like that, it means that we can't jump, okay? And if the ball instead is over there, and if the ball is right here on the floor, you cast a ray below, like this, and the collision point of that ray should be right here, meaning that we should be able to jump. If it's lower than, I don't know, 0.1, we say, okay, you can jump. That's the idea. Let's go, let's do it in our code. It's similar to raycasting in Three.js, but we are going to do it in Rapier, okay? Because there is a Rapier word. We could have done it in Three.js because we have a Three.js word, but it's more related to the physics, so we're going to do it in Rapier. And actually, we are going to learn some things along the way. So, to set the origin of the ray, I remember that we want to cast the ray like right below the sphere. We are going to retrieve the body position, because if we moved, see, we are a bit away, we don't want to cast a ray there, we want to cast a ray under the ball and its current position. So first we need to get that position. It's in the jump, okay, it's right here. We can keep the apply impulse, this one here. So const origin equal, and we are going to get the sphere position. It's going to be body current translation, translation, like that. And you can log it if you want, or just watch my screen, it's kind of the same. If I do it here, see, it's 0 on X, 0 on Z, and it's a bit higher on the Y because it's the center of the sphere. And if I move slightly on the X, I do it again, the X got negative and the Z didn't move, and the Y is near the same. Okay, but that's the center of it. Okay, currently the origin that we got is the one, I'm gonna get it, is right here. Okay, we need to do it here. So we need to move it down slightly, and to do that, well, there is no trick. You can just do origin.y minus equal 0.31, like this. So now it's below the ball. Why 31? Because the ball is 0.3, and I want it slightly above. Okay, I'm just adding a slightly above the sphere. For the direction, we want it to go downward, so there is no the direction of the ray, so no issue here. We can do, I'm going to do it like that. Direction equal, we send a vector 3, x to 0, y to -1, so that it's downward, and z to 0. Okay, so we have the origin, we have the direction. To create a ray, we need to use the Rapier library. This is where things get a bit tricky. We need, if you check the documentation, you need to instantiate a ray from Rapier, not React 3 Rapier, I'm talking about Rapier. There are two ways of accessing the Rapier library. First, we could do something like that. Will it work? Can you guess if it's going to work? So I import everything from Rapier, and I should get access to this. This is the way of importing a Rapier if you just want to do a Rapier without a React 3 fiber. So console.log, is it going to work? Yes, it did work. And I have access to the ray somewhere over there, the ray. It's working because we added the React 3 Rapier, and this React 3 Rapier added the Rapier to the node modules, but we didn't added the node modules ourselves. Okay, we didn't add it to the package JSON, we didn't do npm install. That's why I don't recommend doing that. It doesn't make sense. We are relying on dependencies of dependencies, and if React 3 Rapier changes, maybe it will break something, wouldn't make sense, but I think it's bad for your code, okay? So we're going to do it a bit differently. The second way is to use the use Rapier hook provided by React 3 Rapier, because yes, React 3 Rapier provides you an access to this Rapier one, and it's the one that React 3 Rapier is using, so we are sure that it's going to be fine, and we are using the same version also. So let's go. We are going to import it from React 3 Rapier, so this one here, it's a hook, so it's use Rapier, and we are going to get a bunch of things inside this one. In there we can call it const, and I'm going to destructure it already and do use Rapier. Okay, if you do it like I'm going to do a quick test because I can't help myself but to show you this. If you just use Rapier, you get a bunch of information like expose, etc., some stuff related to the simulation with React 3 Rapier. All we want is access to the Rapier library, so it's Rapier. So I'm going to destructure it and call it Rapier, like that. Rapier, and now we have access to those. And in there is the same ray that I shown you before by importing it ourselves. Okay, cool. So we can just call it Rapier like that. Okay, we can remove the log. It's done already. Back to our jump. We have the origin, we have the direction. We can create a ray. We're going to do const ray equal new Rapier dot ray, like this. And when you create a ray, you need to provide the origin and the direction. Guess what? We already prepared those. That was the whole point. So origin and direction, like this. save. It's not doing anything for now, but make sure that you didn't do any mistakes. Give it a jump like this. Okay, it's still working. Great. Now we need to cast the ray, but we are going to cast the ray against something, the object that we need to test. We are going to test with the whole world, not just the floor, so that maybe the ball was actually on top of an obstacle or something else that you added, and we want it to jump. So we're going to do to test against the whole world. So let's go. How do we access to the world? Well, we can do it using the same use rapier hook. So let's go. We're going to do world. The name of the property is world, and check what we get here. The world is this. This is React 3 Rapier world. It's not the actual world of Rapier. Okay, it's kind of an abstraction of the world. To get access to the world, we need to do row like this. And this one here is the Rapier, native Rapier world. And this is the one we need. So we're going to do a new variable. It's going to be Rapier world equal world row, like that, the one that I just logged before. Okay, this one is the Rapier, native Rapier world that we need for the raycasting. Next, we can test it. So right here, after creating the ray, I know it's a long process, but that's the way it works. Actually, I quite simplified it, but anyway, const hit, because we're going to finally cast the ray and see against what it, I mean the collision. So we call it hit, and it's going to be Rapier world, the world that we just got. Cast ray, because yes, we cast the ray directly on the world. It's not the ray that it casted on the world. It's the world that casts the ray that we created. It's on this direction. Ray, like this, and we're going to log this one here, and it's going to work, although we are going to have a small surprise. Give it a jump, and we get this. Okay, we have some values. Actually, we have the collider, etc. We don't care about that. What we care about is TOI. Nice. This one is interesting. There is a value inside. Let's talk about it. TOI stands for time of impact, which is not very helpful because it's time, but actually TOI is just the distance between the ray that we casted, so from the origin, toward whatever just hit. Okay, but there is something weird. Let's test it. So hit.TOI. What the hell is that value in that case? I'm against the floor. Check that. I'm logging hit TOI, so the time of impact. We are against the floor and we're casting a ray from below the ball, and I'm giving it a jump. And we get this value, but aren't we against the floor? Shouldn't this value be 0? Well, here's what's happened. I'm going to draw it here. We are casting a ray, like from, maybe I should show it like bigger. Imagine that that's the big ball seen from here. Yeah, I think I can do it. No. Yeah, something like that. We are casting a ray from here, but we moved the origin of the ray slightly above, so it's over there. See? There is some space on top of it. And we cast the ray downward. Guess what? Where is the collision? Well, the collision is right here. So it's not accurate, okay? This is our ball. I'm not sure that you understand. This one here is our ball, okay? This is our ball. And we cast the ray slightly below. We don't cast the ray here, because if we do it here, it will collide with the ball. So we move it there, and the hit is with the bottom of the floor. Okay. To fix that, it's super easy. We're going to tell the ray that everything is solid. Okay, meaning that this will be considered as field. Everything inside of it will be considered as a matter. Meaning that this cast here, the ray here, will hit something immediately, and the hit will be right here, and we should get something like 0. Okay, and it's going to fix that issue here. So how do we do that? Let's get back to the slides. That's what I explained, blah, 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 blah. To do that, it's quite easy. The cast ray that we did here, we're going to provide 2 values. We don't care about this one here. I would just provide 10 and true. By providing true, it's going to consider everything as solid, just like I said. This one is kind of the max time of impact. Okay, it's not going to test further away. That's the point of this one. We don't care about it. You just put 10, it should be more than enough. But this one will make the floor solid, and the ray will immediately hit something if it casted inside the floor. Give it a try. I'm going to jump 0. But if now I jump while already in the air, check that. See? I was that distance away from the floor. I can do it again. I was too far from the floor, and I'm going to be able to test that TOI, time of impact. If the time of impact is too high, it means I'm not against the floor. Okay, let's go. We can finally do it. So if hit TOI less than 0.15, or we give it a small chance to jump, even if it's just close enough to the floor, because remember our ball can bounce, and we want it if it just hit the floor and it starts to bounce. We want the player to be able to jump there, okay? Otherwise he will have to wait for the ball to stop bouncing. It will be bad for the gameplay. So if it's less than 0.15, we're going to do the impulse. So this one here, like this, okay? We're only jumping if we're close enough to something below the marble. And check that, I'm going to give a double jump, and now it's not working. Yeah, by the way, hiding double jump might be interesting, but that's a different mechanic. I should not have said that. I want to do it now. Okay, we made a small mistake. Yeah, this one is very interesting. If we apply some changes to player, the component will be destroyed and recreated, but the function we send to subscribed keys will be called twice, and it will make the marble jump twice as high. Quite a long sentence. I'm going to provide you an example. Check my screen. Watch my screen. I'm jumping. See how jump it the ball jumps? Okay. How high the ball jumps? Great. I'm going to do a change. Just watch my screen. I'm going to do console log and do whatever, like hey, like this. Just hey. Okay. So my component was re-rendered, and check that I'm going to jump. What the hell just happened? Do you understand what just happened? Our component has been destroyed and re-rendered. I mean, what needed to be destroyed and re-rendered had been re-rendered, and our use effect has been called again because the component has been, it's a new component, but in fact the ball and the body, etc. are the same. They have been preserved, which is great. That's the whole point of hot module replacement. But we subscribed to the jump again, and the jump will happen twice, and I can show it to you. Like, check that. I'm going to do a console log, like console.log jump, like this. I'm going to remove the console log here. I'm going to give it a reload. Just watch my screen. You don't have to do it. You will have to fix it anyway, but you don't have to test it. So I jump, it jumps once, okay? I do a change, console.log a change, like this. I save, and now I jump again without reloading, and check the log in here. I can clean them. Jump, it jumped twice, because we are subscribing to the event twice. Okay, so we need to fix that. We could fix that. It's fine. The final user won't have that because the final user can't destroy the player or things like that. But you never know. And also it's better for debugging or for other developers that they will be surprised, like, why suddenly my ball is jumping that high? We're going to fix that. First, make sure that you got rid of the various console log that you might have added if you were following what I was doing. Next, we're going to unsubscribe. Okay, because right now in the use effect we are subscribing to the event. What we are going to do is clean up everything, and to do that we are going to need to unsubscribe. So let's go. We're going to do const unsubscribe jump, because this one is only for the jump, and we're going to do a bunch of unsubscribing later, you will see. So we want to unsubscribe from the jump, and we're going to do it. So it's going to be, check that, in here, return a function like that. So inside the use effect, we are returning something, and this part will be called whenever we need to clean things. All right, when the component is being destroyed, this part will be called. Okay, in the case of this use effect, because it's only on the first time, this function we send here will be called when the function is being destroyed. And in there, we can simply call the unsubscribe jump. Okay, yeah, because by the way, this subscribe keys, so it's to subscribe to stuff, but it returns a function to unsubscribe. Okay, so this one, let's test what we get. Again, just give it a reload. You can just watch my screen to see what happened. I'm going to test it again. I'm giving a reload. I would just put one more jump here. So jump, okay, jump, like that. I mean, one log with the jump. It's jumping, okay, it's working perfectly. I'm going to do a change in the player. So console log a change, whatever, it doesn't matter. I'm going to save, I'm going to clean the console without reloading, and I'm going to jump and we have only one jump because we unsubscribed, okay, automatically when the component was being disposed and recreated. This function has been called and we unsubscribe from the event. All right, nice. Remove the potential console logs and remove from, so in experience.js, remove the debug like that, because we are done with creating the whole levels and the player rigid body, etc. It's working nice, we can move, we can go away, etc. But for now, we have to move the camera using the orbit control, so it's not very convenient. We want to animate the camera. Okay, and we want that camera to follow the marble, and it will stay behind the marble and with a smooth animation, all right? You will understand later. At the beginning, we won't use the smoothing, and you will understand why we need to smooth the animation. First of all, we don't need the orbit control, so we're going to get rid of it, so you can remove it from there, and you can remove it from there too. It's cool to have an orbit control for debugging. Maybe you can like use lever in order to toggle the orbit controls, but we are not going to do that in this lesson. If you give it a reload, by default, the camera is positioned, quite well, but right now we can't move it anymore. And if the marble is moving, well, the camera is not following. So we're going to ignore the smoothing for now. Okay, I just want the camera to follow the marble and to watch at the marble. We're going to do it in the use frame inside the player. Okay, the camera will be handled in that class, in that component too. So inside the use frame, that use frame here, we're going to add some big comments just now. Actually, you probably added a bunch of comments. This one will be about controls. Okay, I put controls there, and this one now is about camera. Okay, because we have too much code in one use frame. You can create multiple use frame, by the way, but let's keep just one. Would be weird otherwise. And in there, we're going to handle the camera animation. So first of all, retrieve the position of the body with the translation. Yeah, const body position, because if we want to move the camera to follow the marble, we need to know where the marble is. So body position equal body.current, and we use the translation. Remember this one? You can test it, log, and on each frame we get this. If I move left, check the X. Okay, it went negative, and if I move right, positive, and you can try with the Z, negative, and if I move back, positive. Anyway, it's working great. So we're going to use this one. Let's remove the log like this, and let's move forward. We're going to import 3 from 3 because we're going to use a bunch of vector and method on those vectors. Let's use the 3JS vectors. It makes sense. So import all as 3 from 3 like this. Next, we're going to create the camera position variable. So it's going to be in the camera part of the use frame. We're going to do const camera position equal new 3.vector3. By default, the vector 3 is at 0, 0, 0. So for now, it's not good. What we're going to do is copy the position from the marble. So it's going to be camera position copy, and it will take all the values from that one here. Okay, so body position, yes, this one is a vector 3 from Rapier, and this one is a vector 3 from 3JS, but most mathematical classes like vector 3 are compatible, so we can use them. We don't want the camera to be inside the marble, so we're going to move it a bit away. We're going to do position.z plus equal, because plus is behind, 2.25. You can put whatever value if you're not happy at the end. And y a bit higher, so it's going to be 0.65, like that. Okay, great. This is where the camera is supposed to be. It's not updating the camera yet, but we are going to fix that right after. We're also going to create a camera target, because we want the camera to look at not the marble, just slightly above, so that we can see the rest of the level. So we're going to do the exact same thing, const camera target this time, so there is the position and now the target, new 3.vector3, so it's exactly the same. Then we take it from the body position, it's the same, so camera target copy, and it's the body position. So doing that means that the camera will look at the marble, but we are going to move it slightly above it, so camera target.y plus equal 0.25, okay, so that it looks slightly above the marble. I can give you a quick drawing so that you understand what I mean by that. The camera is going to be, what can I use? I don't have a lot of color left. So this is my camera, okay? And I'm going to draw it like that. It will follow the marble like this. This is my camera. And it will look at it. What color can I use? Oh, I don't have any more color left. Anyway, I will use this one. It will look slightly above it. So it's going to be somewhere over there, okay? Slightly above. This is the center. We want to look slightly above it so that we can see the rest of the level over there. That's the idea. Okay, let's move forward. Since we're in a use frame, we already have access to the camera because it's time to move the camera. We can retrieve the camera in various solutions, but in there, in the state, we can retrieve the camera. We already put that state variable because we wanted the delta. We didn't care at that time about the state variable, but now we can use it because the camera is inside this one here. So let's go at the end here. We have the position, we have the target. We're going to do state.camera. That's the way of accessing the camera. Position, copy. So we are not changing the position directly by this vector here. We are copying the calculations, the camera position here. We are copying the values inside the position of the camera so that we preserve those. You don't want to change the position vector directly. And then we can ask the camera to look at the camera target like this, and check that out. It's already working. Nice. And it looks like that. It was quite easy. If you organize and you know where you're going, it can go quite fast. And it's working, but it's a bit rough. See that animation? It's working, but we want something a bit smoother. We're going to use the classic lerping technique. The idea of the lerping, we've talked about this already, is that on each frame, the camera will get slightly closer to where it's supposed to be, and it will keep doing that on each frame. Okay, I can't help myself. I need to do a quick drawing. Let's imagine that this is a bunch of, I'm gonna do like that, okay. Okay, those are frames, okay? This is the position of the camera. I would just explain it like if it was just one value, one float, but then you can imagine that it's in 3D. This is the destination, okay? We want that point to go from here to here, but not straight away. We want to do it like smoothly. What we are going to do is that on each frame, we will get slightly closer. Let's say half of the distance. So half of the distance, we will go there. Okay, and this one can be always at the same position. So something like that, and something like that. Next frame, okay, those are frames. We will get half closer, so we will get there. Next frame, half closer. Next frame, half closer. Next frame, half closer. And as you can see, it did something like that. So first it was fast, and then it slowed down. And even if this value changes, it will always try to catch up with this value. But the closer we get to that value, the slower the animation will be. And this is just the way of smoothing values. And we call that lerping because we get one portion of the value between the initial value and the end value. Right here, I put 0.5, but in our case, it will be maybe like, I don't know, like 1/10, something like that. So that's the way of lerping. So yeah, we're going to do that. First, we need to create two new vectors outside of the use frame, because those are just like right now, this is the destination. Okay, this is the orange one. This is this one here that we calculate. It's the direct, just the destination. Now we need to have new variables on where the camera is right now, and this one is the green one that we get closer to the destination. We could do it directly on this one, but I want to show you how to do it with the use state that we have been using already multiple times this way. We just want to create two vector 3, so the position and the target, just once when the player is being created, and we are going to use state like we did earlier. So use state like that. Next in here, so I will put it, let's say over there. Yeah, why not? Const, and I'm going to call it smooth, because it's going to be the smooth value of the camera position. So smooth camera position, use state, and like we did earlier, we are going to return, to send a function that will return a vector 3. So new 3.vector3. Okay, this one will be created just once for that component. We can do the same with the target. So it's going to be like this, and it's also a vector 3. And that's all. Next, so we have those vectors that are equal to 0. Back in there, so before copying the result to the actual camera, So right here, we're going to update those smooth camera position, and we're going to make them go closer to the destination, so the camera position and the camera target, but 1/10 closer. And on the next frame, 1/10 closer and 1/10 closer. That's the idea. So smooth camera position. We're going to use the lerp method, which does exactly that. It will take the initial value and move it a bit closer to the destination value. And for us, the destination value is the camera position. And we're going to go 1/10 closer. So it's 1 divided by 10th or just 0.1. It's the same thing. And we're going to do that with the target 2. So it's going to be like this. So we do it for the position and the target. And in there, we're going to use those values instead. So the smooth camera position and the smooth camera target. And check that out. Just by doing that, it's much smoother. The camera tries to follow, just like someone with a camera would do the same. If something moves super fast, that person will try to catch up with it, and it will take time. So that's a bit more realistic, and it feels much better. It's much smoother. See, the ball has time to go a little on the left of the and on the right of the screen. But we did a mistake, classic mistake. Devices with different frame rates will have different results because we're going 1/10 closer, but someone with a higher frame rate, well, this one will be called more, and the animation won't look that smooth. Anyway, we just need to use the delta time again. So we're going to multiply this one by delta. Delta that we already have access in the use state. Let me show it to you again. This one here that we have been using for the torque and the impulse. We do that, but unfortunately delta is quite small, so we are going to change 0.1 to 5. We need a bigger value, otherwise your camera will almost not move. And it looks like that. And it will look the same regardless of the frame rate. Okay, it's a classic time-based animation. Next, the initial position. Yeah, let's improve that too, because it's quite easy. When you reload the page, the camera seems to come from the floor, like it just do like a little movement backward like this. Not very interesting. It's not a big issue, but it's not very interesting. What we're going to do is put the initial position super far away like this, so that when it starts, it will get closer and we will get some kind of bird view and arrive on the marble. Super easy, check that. We're going to change this one and put 10, 10, 10. So that's the initial smooth camera position. It's far away. And then it will get closer because the destination of the camera position is right behind the marble. Let's give it a try and check that. We get this nice animation just by setting this value here. Let's move forward. Let's talk about the shadows. Yeah, because check that. Now that we can move the camera, we go there. Oh, I'm so bad at the game. And the shadow is gone. What's happening here? The shadow stops after a few traps. Yes, indeed. The shadow is being rendered by an orthographic camera. You remember this one? Let's imagine that this is our level. We have the light, so the light is over there, okay? And it's casting so light, and it's going to do a render, so something like that, on our level. And I created quite a big render, like something maybe like this. And see, there it's not going to be render. Okay, it will render this part here, but it will stop, which is why the shadow suddenly is cut over there. So we need to fix that. There are multiple solutions. You can make it huge, like maybe we can have a huge area like that. But first, the shadow quality won't be that good. And also, if the level is bigger, at some point there is a limit to making the light bigger. So it's not a viable solution. Now we need something else. What we are going to do is make the light follow the marble. Just like that, when the marble will move forward, the light will also follow it. So that, yes, in the depth, like over there, we will be able to see that the shadow is not rendered, but it's far away, it's small, we don't really care about it, it's fine. And in there, we will have a clean shadow, like it is right now. So let's do that. It's going to be quite interesting. First, it has to be in the light component. That's why I told you that it was good to separate into different components. We will have some codes in there. First, we need a reference to the directional light because we're going to animate it. So we're going to import use ref from the classic React. Okay, you know that. Then we're going to associate it with our directional light. We don't care about the ambient light. So it's going to be ref equal, not use ref. Oh no, I forgot to create it. Yeah, I'm getting a bit tired. This lesson is quite long. I hope you don't mind. Light equal use ref. I forgot how to do simple things. And ref equal that light. Okay, I give it a save just to make sure I didn't do any mistake. It seems fine. Since we are going to animate it on each frame, we need to use frame. So import use frame like this from React 3 Fiber. Okay, nice. Next, we are going to call it, so right here, use frame. Use frame, yeah, I'm doing a lot of mistakes. Use frame, we provide a function like this, and we are going to retrieve the state. Why the state? Well, because instead of using the sphere, the marble, we're going to use the camera. Okay, because we can access it, it's much easier than trying to retrieve the coordinates of the marble in there. And also because maybe at some point you will do an animation, I don't know, like the level starts and the camera is going through the level to show it to the player. You want the shadow to follow the camera in that case, not the marble. So we're going to access the camera from here using the state. And in there, sounds easy, we're going to do light current position Z, okay, because we only move it on the Z, so the Z is over there. That's our light, by the way. I'm not sure that it's clear enough, but that's our light, tuk, 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 and it does like this, okay? That's our light. We're going to move it on the Z only, okay? Because we don't need to move it on other axes. So I put X, obviously, equal state.camera.position.Z. I'm going to add one. I forgot why. We don't care about that anyway. We're going to play with those values because we will have a small issue. Oh yeah, no, I know, because +1, because it has to be a little backward so that there is kind of an angle. They are not perfectly aligned with the camera. There would be a boring shadow. We put it a bit backward so that we can see more clearly this part. Like if we don't remove, if we don't do a +1, check that. It's a bit in the dark. If we put like, I don't know, -4, it's way too dark, so it's slightly behind. So +1, like this. Okay, is it working? Let's test. I'm going to move with that. Okay, seems to be working, but oh wait, there's something weird happening. First, check the shadow. See that shadow orientation? It's going like in the end, and now it's going backward. What the hell is happening? Here's what's happening. I'm going to draw it on the side. We have so many drawings. I like it. This is our floor seams from the side. This is our marble, like this. This is our light. Okay, it's doing something like that. Okay, and we move that light with the marble. So when the marble goes there, the light is supposed to be there. Okay, because it's following it. But here's the thing: the camera, the directional light, has a target, and the target by default is at the center of the scene. When we move the camera, the light there, where it was still looking backward at the center of the scene over there. So our marble is there, the light moved, but the light is still looking at the center of the scene. So we need to play with that target. How do we do that? We can update it the same way. So we're going to do light, current, target. That's the way of accessing the target. It's an object, meaning that we have access to the position, and we're going to move the Z2. And we're going to say that the target is, the Z of the target is where the marble is. Makes sense. State camera, the camera, not the marble. Position.z. Let's test. The code is right, but check that. Not working. See, the shadow is still doing the same, is having the same behavior. What's happening is quite interesting. It doesn't work because the target matrix isn't being updated. The target matrix, we are changing the position. Until now, when you want to transform something, you are updating the position, rotation, and scale, right? Makes sense. But internally, Three.js will have a matrix for those. A matrix is like we did, with the instances in the physics lesson. It's like the combination of the position, the rotation, and the scale. And Three.js will use that for multiple things, like positioning the vertices of the object. Okay, but Three.js only update a matrix of an object if the position, rotation, and scale change, but also if that object is in the scene. Why? Because there is no reason to update the matrix of an object that is not even visible. And by default, the target is not in the scene. Yes, we do have the light, but not its target. the target is an object and it's not in the scene. So you can update the position, the rotation, or whatever you want with it. The matrix that is then used to orientate the light won't be updated, just like if the target is still at its initial position. So how can we fix that? Maybe you thought of it. We can add the target to the scene, and we could do that. That's clearly, it's not even easy. Don't do it, but it would look, we would need to do it outside of the use frame, but it would be something like state.scene.add and then do something like that. Don't do it because it must be outside of the use frame. You don't want to do it on each frame. That's one option. You add it to the scene, you change its position. 3GS will check at it and say, oh, you're in the scene, your position changed, I'm gonna update your matrix. Or we can update the matrix ourselves. And to update the matrix, it's quite easy. We're going to call light current target, so it's the object, update matrix world. And that's kind of the general matrix for the object. It's the world matrix. We give it a save. I'm going to move like this and check that now it's working. The shadow, the light, the target, everything is following perfectly. Nice. Currently the light is focusing on the camera. It's fine, but most of the shadow is behind us right now. Okay, because the light is perfectly focused on the camera, and there is shadow behind us. It's a bit of a waste. What we're going to do is move it forward a little. Okay, it's a silly trick. We just move everything forward. So we're gonna do -4 because forward is minus on the Z, and -4. So we both move the target and the light like this a bit forward. And check that, it's going to go a bit a bit further away. Next, see, our game is working, we can play around, but we're missing some very important stuff like game mechanics, but also the interface, and we're going to work on the interface. The interface will be composed of 3 elements. There will be a timer that will be on top over there so that we know how long it took us to finish the level, a restart button at the middle when we reach the end of the level, and a keyboard interface showing us the WASD keys and the spacebar. Why? Well, because the user will understand that he has to press those keys to play, and it will also be the opportunity to have fun. Anyway, we are going to put all of those in a new component. The interface will be done in HTML. Sounds weird, we have been doing some WebGL for a while. It's much more convenient. I mean, if you want to add text or buttons or things like that, maybe don't try to do it in 3GS. It might be overcomplicated, okay? It might be overkill. Instead, just create some HTML interface on top of it. And since we are using React, it's going to be super handy. It's easier with React to create a button, etc., and text that changes, like for the time, for those little buttons that we change when we press them. It will make sense once we do it. Anyway, we are going to do it in HTML, meaning that we have to do it outside of the canvas. Okay, the canvas, this one here, its purpose is only for React 3 Fiber. We need to create the interface outside of this one here. So let's go. First, we're going to create it. So interface up interface.js, like that. In there, we're going to export the default function interface. It's the usual, just a component like any component, and return null for now. In index.js, not experience, because experience is in the canvas. We need to be outside of the canvas. So in there, we're going to import it. So let's go import interface from interface.js, like this, and we are going to instantiate it inside the keyboard controls, because we are going to need the keys being pressed in the interface, like that. Okay, make sure you have no error, make sure you save your interface.js, and in the interface.js we're going to have some kind of container for everything that will be inside. So it's going to be a div with a class, not a class, a class name. Remember that? It's React interface, like this. For the CSS, we're going to keep things very simple. We're not going to use any framework or whatever libraries like Sass or Stylus or whatever, okay? Let's keep things simple. This is not the topic of the lesson. And we're going to put the CSS right here in the style.css file. And we're going to start by making the interface fill everything. So let's go. I'm going to add some comments this time. Interface, like that. And I'm going to target the interface. Remember, we put an interface class on it. Position fixed. There will be quite a lot of properties to write. If you're not interested in CSS, just take it from the lesson below, if you find it, because the lesson is quite big. The width 100% and the height 100%, like that. Okay, you can't see it, but it's right here. I can actually do it like that. Yeah, I've debugged it. See, it's right here. So there is the canvas somewhere over there, okay, inside some divs, and the interface is on top of it. Nice. First, we're going to make sure that the user can't click on the interface. Yes, he will be able to click, the player will be able to click on the restart button, but that's the only thing that we want the user to be able to click on it. So we're going to deactivate any click on the rest of the interface by doing pointer events none, like that. Okay, and now if I try to get it, I'm getting the canvas. See, I'm trying to get it with that tool here. I can't select it like this because the mouse doesn't work on it anymore. Okay, about the font, we are going to use the usual Bebas Neue font from Google Font. So it's this one here. I really like this one. I don't know why. Anyway, open the link. As always, check the links. Yeah, like this, like this. So if we want to use this one, you need to activate that one first. And you do that, sorry, by scrolling a little and selecting which variation you want. We want the regular 400. It's the only one for Beba. And we can just click on regular 400. And in there, it should open the interface already. There, you will be able to integrate it using that code here. Okay, so you take that code here. I'm going to make it change the layout, and you paste your code inside the head of your index.html, which is in the public folder right here. And now we have access to this font in our CSS. Next, we're going to apply the font family on the whole interface. Let's be lazy. So font family, and actually the code is this one here from Google Font, and I can just copy and paste it like this. We have a fallback in case this one is not being loaded or it takes too long to load. We will have the cursive that I think is available in most computers and OS. Okay, no difference, but on that interface we have here, we will be able to put text, and that text we have the Bebas Neue font. We're going to start with the time. Remember, we need the time, the restart button, and the controls. Let's do the time first. We want to display a stopwatch so that the player knows how long it takes to finish the level. For now, we will just put 0.00 on it, and later we will update it while the player is playing. So let's go. We can go back to the interface.js. We can close the index.html, but keep the style.css open. And in there, we're going to add the time. So I'm going to add a quick comment, time. I'm going to create a div. Actually, I think you can use this kind of shortcut. Yeah. You just write point times. I mean, if you're using a VS Code, you just write point time like this. You press enter or tab and you get this. And in there, we're going to put 0.00, and it has the right class, and it should be a class name, not a class. Okay. I'm going to add some line breaks. Next, in the CSS, we're going to add it. So in there, I'm going to target the time. Let me check. Yeah. We're going to add a comment too, like this. This part is a bit boring because we are just filling just the interface, and we want to do some Three.js and React 3 Fiber, I know, but we need an interface, and it's much better with it. So position is going to be absolute, top 15%, left 0. You will see how it looks right after. I'm just using those values. So width 100%. Color, we are just going to set it to white, sorry. I think everything will be white at the end. Font size to 6 VH. Why? Well, so that the interface adapts to the size of the viewport. Background, we're going to put a black background, but change the opacity on it. So at the end, we put 33, like this. Padding, top, we put 5 pixels, just a small padding. And text align center, like this. Padding top actually is to make sure that it's centered vertically. And it will look like that. Nice, it's working. Cool, we just have the time right here, and we will update it later. We can't select it because we put pointer event none on the whole interface, which is fine. We don't want the user to select it. It's a game, so it makes sense. Next, the restart button. It's kind of the same thing. The restart button, we will just add it there. It will be always visible first, and then later we will hide it according to the progress of the player in the game. I mean, the player needs to finish the level first before showing the restart button. So let's be lazy and duplicate the time like this. We're going to call this one restart like that and put the restart class like this. And we're going to write restart in there. What do we get? We get this one here. Okay, we need to position it. It's a bit like the time. We're going to target, so we're going to be lazy. I'm going to copy this part here so that I can reuse it. We have restart and restart. Okay, we are targeting the restart class. Display flex, so that it's easier to center stuff inside of it. We could have get rid of this one actually. Justify content center. There was more stuff in there, that's why I used the flexbox. Anyway, position absolute, like this. Top 40%, left 0, width is going to be 100%. It's a bit like the timer. Color, we want it to be white, like this. Font size, I've set a font size, a fixed font size to 80 pixels. You can change the interface if you're not happy with what I put, obviously, but maybe wait at the end of this section. Like same background as for the time, 000033 at the end. Padding top, damn, we have so many padding top. I think I will copy and paste the next one. It's quite long. And pointer events auto, like this. Why I put pointer event auto? So that the restart button can be clicked. It will override the one we have here. So we deactivate all pointer events on the interface, but we activate it back on the restart. And cursor pointer, so that it looks like a link that we can click. See, my cursor is going above it and I can click it. All right, nice. So we have the time, we have the restart. For now, we can click on it. It's not going to do anything. Next, we're going to handle the keyboard's inputs. What I mean by that is that, as I said earlier, we're going to add, some buttons here that looks like the keyboard, like the arrows, and also the space bar below it, so that the user understands that this is how we play the game. If you just put that, the user will probably understand that he has to press those keys to play. So WASD keys or the arrows. That's nice, but we are also going to have some fun by making those inputs highlight when we press them on the keyboard, okay, so that we have some feedbacks, visual feedbacks. Nice. So let's go. I think that's the part I'm going to be a bit lazy. So back to interface.js. Yeah, check that. I will copy and paste it. So check below. You have some code to copy. Just search for maybe this one here and search for controls or class name controls and just copy it, because this part will be super boring if I do it with you. So pause the video, take the code. We will do the same with the style. Okay. So right now they are somewhere over there. I have no idea because there is nothing on the screen as long as we don't have the CSS. And for the CSS, again, I'm going to be lazy and just copy that CSS here. Yeah, I'm sorry, but this is not a CSS course. And we get something like that. So you get the idea. There is one thing important. It's that when the control key, so those are the keys, so this one has a key class, this one has a key class, etc. When they also have the active class, so this one here, the button will be brighter, and I can show it to you. Don't have to do it, but I will show it to you. So where is my interface? It's over there. Controls row, I'm going to do on the space bar, so it's this one here. If this one also has the active class, check that, it will be brighter. Okay, I can do it on this one too. Sorry, it's over, where is it? It's this one here. This one, I'm going to add the active class and it's brighter. Okay, so when the user will press those keys, we need to add the active class. Okay, so let's do that. In interface.js, I'm going to close the style.css. We don't need it anymore. We need to access the keys that are down. Remember that interface is inside keyboard controls, meaning that we can access the keys that are being pressed. We're going to import it. So import, and it's going to be use keyboard controls from, I'm going to use simple quotes because I prefer, React 3 Dray. Okay. In there, using that, yeah, we have been using it to retrieve a subscriber and a getter. Now we are going to use it to retrieve the keys, but as reactive data. We are in a more React context, meaning that we want to retrieve this information as reactive data. If that data changes, the component will be re-rendered. It's kind of the traditional way of using React to create interfaces. So let's go. How do we do that? First, we can try by doing const controls equal use key. So I just call this one here, this helper here, and check what I will put there. I will send a function, and that function will return, so I can get the state as an argument, and I will just return that state. And since I wrote it like that, I can just remove the usual, it's an arrow function. I can remove the return, the curly bracket, the opening and closing of the curly bracket, and we get this. And I will explain to you what's that. But first, let's test what we have inside that controls variable. And check that. We have forward, backward, leftward, rightward, and jump, all to false. And if I press, so W for you, see, went through, true, false, true, false, true, false, and we get some information just like that. If I press using the arrow keys like right, see, the right word, I switch to true, and we get that. And the console log is being called whenever something in there changes. It's the React way. This is reactive data like we learn in the React lesson. So control is an object containing all input as properties, where each property is true or false depending on whenever the key is pressed or not. So you got this one. The parameter we sent is a function receiving the state as a parameter, and we are returning that state. See that this is, and we talked about that already, this is a selector, meaning that we want everything. But do we want everything in there? Well, yes. But see, there is a forward, backward, leftward, rightward, jump. We need all of them for this. But you should try to avoid doing that. Because if at some point you add more controls, I don't know, like a pause key, or you press enter and you can, or T, and then you can speak with other players or whatever. If you add more controls, pressing those keys will also re-render that component, and maybe you don't want that behavior. So what you should do is just select what you need. That's the idea. So in our case, we want the forward, backward, leftward, rightward, and jump, all of the keys, but we are still going to retrieve them separately to make sure that we are only getting what we need in case suddenly we add more controls. So let's go. We're going to do for the forward. So forward like this. And instead of returning the whole state, we return state.forward. Just like that. It's not that complicated. There are other ways to write this, but this is the simplest, I think. So forward, then backward, then leftward. I don't like this order, but anyway, you know, I like the clock order. So top, right, bottom, left. Rightward and jump like this. And right now you can test, like if you I'm going to test on the jump. See that? I'm going to press jump, resist, press, resist, press, release. Nice, it's working. We can remove the logs because we don't need the logs. We just need to update the interface, and we're going to add the active class to those key here. See those? There is 1, 2, 3, 4, 5 of them. We need to add the active. You can try to do that yourself. Add the active class if the corresponding keys are being pressed. So first, we're going to concatenate, and we're going to concatenate using backquotes. So I'm going to replace all of them at once. So not this last one here, I will do it after. Like this, I'm going to replace by this. Okay, so that I can concatenate something in there. I will do it also for this one here. Like that. So it's going to be, oh, I'm messing up with everything. Just watch the final result. I'm doing some mistakes. Like this and like that. Okay. That's the idea. For now, we have the exact same result, but we are sending backticks, and we can concatenate strings inside of there. And we can do it like, let's start with the forward. I'm going to concatenate something, $curly brackets inside the backticks. And if forward is true, so I'm asking a question, this is the ternary condition. If forward, then I will add active to it, otherwise I will add nothing. There are many ways to write this part here, but I wanted to show you this one. Okay, so we will, if forward is false, we will just have key. If forward is true, we will have key and then active. Make sure you have a space right here, okay? You want a space between those two classes. Let's give it a try. I'm going to press up and see. It's working. Nice. See that little button here? It's working. We can do the same for the other ones. Let's be lazy and copy and paste. I'm going to do all of 3 like this. This one is the left word. Yeah, make sure that you have the right order. This one is the back word, and this one is the right word, like this. And I can also add this one here, and this one is the jump word. And I will add it after the large, so that I have exactly the same thing as in the lesson. Okay, nice, 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 and jump. Everything is working. Make sure you have the same thing as me. It was quite tedious, so maybe pause the video, and we're going to move forward. Our game is looking really good right now. We have the interface, we can move around, we can go down to the end of the level, we have the obstacle. It's looking really cool, but we are still missing game mechanics, okay? We need it to work like a real game. The game mechanics are, we need the restart button to be clickable, so this one here, and to only be visible when we finish the level, okay? We need the timer to display accurate information, and we need to reset the marble if it falls out from the map, because check that, I fall and I will fall forever and I will never be able to play the game. So we need to fix all of those, and there's actually a bit more game mechanics, but those are the main mechanics. Those information needs to be available in multiple components. Okay, these mechanics concerns a bunch of components. We will have some time information, some phases, some quite a lot of things, and we need to access them in many components. Like the restart button, we need to show it when the game is finished, when we are at the end of the level, and we need to update this in the player. So we need to have what we call a global state. You don't want to put values that go up and every values are set in the index.js and spread those values downward and a bunch of function. It will be super messy. Instead, we want kind of a global state, so a global information, and we can access it from any of the components inside that global state. And I have good news, we can do that using the stand. And guess who is working on the stand? Yeah, obviously the Poimanders, as always. The Poimanders collective is working on this stand. So yeah, by the way, there are multiple solutions to handle global states. The stand is actually not the most popular one, but it's really cool. It's quite simple. I think I've compared with other global states, states management and global state solution, and the ones are super complex, overkilled, and sometimes they don't even work with React 3 Fiber. So just use the stand, it will work perfectly. And it's the simplest one, I think. So let's go. Yeah, by the way, keyboard controls that we have been using for moving everything, the marble and the updating the interface, is using the stand. So that's kind of a good example, because we are also going to see some similar things on like the selectors, etc. So let's go. Enough talking. Let's add this thing to the project. I'm going to do npm install the stand. And I'm going to force the version to 4.1. Okay, make sure to use the same version as me to prevent surprises. If you get some vulnerability warnings, you can ignore them. And I'm going to install it. Let's wait a little. Yeah. Okay, I can close this terminal, and my server is still running. So those work as a store. Usually all those state management are using that same term. It's store. We need to create a store. It's where we store information, and all the components that we need will have access to that information. We're going to create only one store, but usually for more complex application, you end up with a bunch of stores. And initially, when I created this game without the keyboard controls, I had to create multiple stores because I had to create one just for the controls. So we're going to do it like if we had multiple stores, but at the end we will, for now we will in this project we will just have one store. So let's go. In the folder, so right here inside the src folder, I'm going to create a stores with an S folder, so src stores. In there, I'm going to call my first store, my only store, useGame.js. And you might think, useGame like a hook? And yes, that's the idea. We're going to use our store like we use a hook. Hooks can do a lot of things, and this hook will let us gather information about the game and also subscribe to information. So it makes sense that we call it use game. You can actually probably call it any way you want, but it's better to call it like a hook because we're going to use it as a hook. In usegame.js, we're going to create our store, and to create the store we need to import create, makes sense, from the stand, like that. Then we can create the store, so just create, and we're going to export what has been created like this, and we're going to export it as default. Next, in there, so maybe don't save yet, I'm not sure, you might get some bugs. Anyway, we don't have information yet, so it doesn't make sense, and we're not importing it yet, so it's okay. We're going to send a function, and I'm using an arrow function, and we're going to return an object, okay? This, to the create, we send a function, and we just return an object, and this is our state, and this is where we're going to put a bunch of information about our game, okay? The phase, the amount of blocks, etc. Any information that we need to be available globally, we will put that information in there. Okay, nice. We're going to start not with real game mechanics like the phase, etc. We're going to start a baby step with a blocks count so that it serves as an example. We don't really need that, but I want to show you an easy example. Blocks count. Okay, we added our first information, our first property to the store, and it's the number of traps we want, and set it to 3 so that we can test more easily, just 3 blocks, and we just save. So we have our store. It's inside a file that we are not using yet. We're going to retrieve that information, so the blocks count, in the experience.js file. So let's go. In experience.js, we're going to import our store, which is kind of a hook. So import use game, okay, that's the name, from stores use game. That's just the file, okay? I'm going to save. Nothing is happening. If you get an error, you probably did a mistake, so I will show you my code again. Check that you have the same thing as me in there. Okay, back to experience. We have this hook, so our store. We're going to access the value in there. So we're going to do const blocks count equal, and that's super easy, check that, use game, and we send a function, and you probably know where this is going. Use game, we send a function. In there, we're going to retrieve the state, which is our store information, and in there, we're going to say what we want to retrieve. We are going to return it. We want to retrieve the state.blocks count. Okay, that's the information we want to retrieve. This is maybe you can guess it. We have been using similar things in this lesson. This is a selector. We will have a bunch of information in our store. We just want to select this information here. We send a function that will return that information that we want to select, and it's this one. And you can test it. I think you can just log it there, see, and we get 3. It's a bit far-fetched, but it's first we can optimize it visually, so you can remove the return and the curly brackets, and it will optimize a lot of things. It will only re-render that component when this one is changing. I mean, at the end, it's not that complicated, and it's super useful. Okay, so we get the blocks count. Let me check. Yes, we wrote it this way. Yeah, this is a selector, and it's the same technique we use for the controls. I told you keyboard controls uses the stand internally. So it's very similar, just like the way to subscribe to events, we will do that too. If that value changes, the component will re-render, which is why it's better to only select the data that you truly need to, in the component. You can retrieve everything, I can do that, okay? In there you will get all the information in the store, but if any of the information in the store changes, the experience component will re-render. And this can be very bad, okay? Especially if you, I don't know, if you have an information that you update on each frame, this can be very bad. So if possible, try to only retrieve the information that you need. In our case, it's blocks count. Nice, so we have access to it. Let's use it because we can. We're going to do a level. It's the count. Remember the count proper attribute that we added? I mean, it's a prop. We can send the blocks count and check that. Now our level is only 3 blocks long. I mean, 3 traps blocks long. it's too short, but at least we will be able to test the end of the level easily. Okay, if you put 300, good luck to test that you're testing things properly. Okay, this was just kind of a test. Next, we're going to do something a bit more complicated. Again, it's kind of just a property, it's the face, but the way we update it and listen to changes on the face will be a bit more complicated. What about that phase thing? We're going to try that with the phase property. So we're going to add phase. We have block counts, we're going to add phase. The idea is that that value, when we start the game, you just start the game. Okay, it's ready. I have my hands up, I'm not touching anything. The phase will be ready. If I start playing like this, the phase will be playing. And if I reach the end of the level, the phase will be ended. Why we are doing that? So that we have kind of an information, a global information on what's the current state of our game, what's the current phase of our game. So that, as an example, the restart button, we will only show that restart button if the phase is, can you guess it, ended. Yes, that's the idea. And we will have a bunch of things depending on the phase. I like to have those in games, especially race games like this, where you have a very linear progression. Like this is the lobby, this is the ready phase, this is the playing part, this is the end part. I think it makes more sense. Okay, let's go. Let's do it. Enough talking. Again, we're going to add a phase ready. At the end, we will have quite a lot of code in the store, so I'm going to add some comments this time. Phases, like that. Okay, cool. It's a bit overkill, but later we'll have a lot more information. We want to update that phase property whenever necessary. Updating the store state, this is where things get complicated. For now, we have just been gathering information from the store, but we also need to update information. So updating the store states can be done through methods directly added to the stores. Okay, we are going to add methods. We have been adding properties, and we're going to add method. A method is just a function inside a property. Like, see, I'm doing a test. Okay, this is a function inside the property, and we call that a method. I just want to make sure that we are on the same page. And we are going to start with the start. Makes sense. So start method on our store. We will be able at some point to call that start method. Don't forget the comma right here. In that start, we're going to update the phase, and that's a bit complicated. It makes sense on how Zusten will handle all this information and make sure that everything is done properly and optimized. But to update the phase, you can't do, I don't know, like this.phase equals something else. You have to use a function that you can retrieve, check that in there, okay? Right here, in the arguments of the function we sent to the crate. So in there, we're going to call it set. Just set. You can call it whatever you want, but it makes sense because it will set the new state of the store. Okay, so this is a function. If you want to update the store from this method that you just created, you need to use set. And we're going to do it right now. We're going to use set, and to the set, follow me on this, we need to send a new function like that. Okay, we're going to add some line breaks. Make sure that you have the same thing as me. That's the part I don't like. We have a very complicated structure. React users and distance user, we say, oh, but you can write it like that, but write it like that. We just make the same thing much shorter. So it's not necessarily bad, but I think it makes it even more complicated to understand. But at the end, it's for good reasons. Anyway, in there, so the set, it's a function that returns the new state, and more precisely, the new state for properties that needs to change. And in our case, we're going to return an object, and we are only going to change the phase, and we're going to change the phase to playing, like that. Okay, we are not going to change the blocks count. Doing that won't change the block counts. It only changes the properties that we send in that object that we return, to the function that we send to the state, to the method that we set on the start property of the object that we send to the crate. That's what I don't like. Anyway, once you get the idea, it's easy. You can just use the same template, and you can make this one much shorter, by the way, but I try to make it understandable. Okay, I'm going to save. I'm going to check if everything is set properly. Yeah, okay, everything is cool. Yeah, by the way, doing that is cool for another reason, is that everything is encapsulated inside the store. So updating the store is done from inside the store. It makes sense, but sometimes when you create a complex application, you have components that are updating everything, and you get lost if you do one. I don't know, if you rename the face to something else, it gets super messy because you need to update that on every component. Right now, we put as much logic of the store inside the store. Next, let's do the same for the restart and the end. Be careful, right now we are going to do a few minutes of coding without seeing anything on the screen. So just make sure that you are doing the same as me. So I'm going to duplicate this and check that, make sure that you have also the comma. So I will duplicate it, see, and duplicate it again. And I have commas between the methods. So this is the start. This is the restart, yeah, that's it. And this is the end. Okay, make sure you have the same. Start, restart, end, like this. And in those, we are going to update the phase. This is not playing. When we restart, we want it to be ready. Okay, because when we restart, we go back to the initial state and the game is ready. And then we are going to press a key and go to playing. And in there, in the end, we're going to set it to ended. Okay, not just end, it's ended, like that. Just give it a reload, no error, great, but we are not using the phase yet. So we have those methods. We need to call those methods whenever we need to, when we move for the first time, we need to call the start method from the store. Let me check. We want to go from ready phase to the playing phase whenever the user presses any of the control keys. Yeah, that's it. Back to player. Why? Well, because it's in player that we handle the controls to start playing. We could have done it somewhere else, but it makes sense that the logic is in the player. We already subscribed to the jump key in the use effect. Okay. Right now we want to call. Let me show you. We want to call this. Where is it? This start method when the player presses any of the keys. Okay. And we did something similar right here when we subscribe to the jump key. Okay. But let's do the same. In there, we're going to do very similar. So it's going to be subscribed keys. And to this one, I'm just going to send one function like this, and I'm going to add a lot of line breaks. I don't know why I did that. Anyway, why not? Like this and like this. Oh, so that it looks like the one before. I see now. I'm going to do a console log any key down. Okay, I'm not using a selector. It's actually kind of a mistake. I'm not a big fan of doing that, but I wanted to show you that you can also subscribe to any key being pressed. So you just send one function to it. Now check that. I'm not touching anything. I'm going to press the space bar and the key was done. Okay, the key changed actually. It's more like this. And if I press, I don't know, other letters, like I will press the O, nothing, the M, the C, nothing is happening. But if I press, like, I don't know, like a row up, now it's working. Okay, I get this information. I'm subscribing to that. But I did a mistake. Just like we cleaned up this subscription for the jump, we need to do it for the this new subscription here for any key actually. So this one we're going to call const unsubscribe any, because it's any key, like that. So remember, when you subscribe to something, you retrieve a function to unsubscribe, and in the return, so in the cleanup phase, we're going to unsubscribe to it, just like we did for the jump. We are cleaning up the events. Okay, so it's working. We now have a way to know whenever one of the controls keys is being pressed, and it's working. Great. Now we want to call the start method. So how do we do that? We do that exactly like we did in the experience.js. We are first going to retrieve it. So we are going to do import useGame from the store. So store/useGame.js. And in there, so at the beginning of our component right here, we're going to retrieve the start. So we're going to do starts useGame and provide a selector, just like we did for the block counts. state.start. We just want this start here. Okay, so we can log it as always and check that this is the code in our start. So it's working. Nice. Finally, when we press any of the keys, so this one here, remember this one that we just created, we're going to call the start. It wasn't that complicated, okay? And now the phase is ready. And if I press any of the key, the phase is now, you remember, it's now playing because this function right here has been called. And you can test it actually. Check that log, starting like this. See, I put a console log in the start to make sure that it's working. I'm not touching anything. I will push forward and it's working. Yes, if I keep pushing it, it will keep calling the start. It's not a big issue, but we will still fix that so that we only update when it's totally necessary. So we handle the start. You can remove the console log if you added the console log like me. We're going to retrieve the method and call it when the marble reaches the end of the level. Yeah, we are going to take care of the end phase. Okay, as I said earlier, we won't see much on screen for a moment. We are just coding so that we have the phases, and then we will make the interface, etc. update accordingly. We did the start. We now need to handle the end, and the end should be called. The end method should be called when we reaches the end. So right here, where the ball is right now at the exact limit. So let's do that. First, we're going to retrieve it. So back to the player.js, which is right here. We're going to retrieve it just like we did for the start. So I'm going to duplicate this one and retrieve the end. Next, we are going to retrieve the block counts. Why? Well, because to calculate if the player finished the level, it's when it reaches this limit here. And we can calculate this limit according to how many traps there is. It's a quick math calculation. If the ball is that far, according to how many blocks we have, it means that the player finished the level. So let's do that. We're going to retrieve the amount of blocks we have. So blocks count equal, and it's very similar. We can copy and paste. So we just want the blocks count, and we only select what we need. It's most of the time better to do that. So we're going to test the position, and we're going to do it on each frame. So on each frame, we're going to test, are we at the end yet? So make sure that you are at the end of the use frame right here. And I'm going to add one more block comments to make sure that we separate the different parts of that huge function. I'm going to call this one phases because we are updating the phases. We already have access to the body position. It was for the camera. And I will test if we are far enough in the level, and I will do body position dot z. If it's less than, because it's negative when going forward, and I would just provide you the calculation. Like, see that blocks count multiplied by 4 plus 2. I don't know why I probably got this one. Yeah, remember, I got this one wrong so many times. Anyway, it's just the formula so that telling that we reached the end of the level. And I will start by doing a console log. We are at the end, or whatever you want to put in there. You don't have to reload actually. If we put everything properly, we don't have to. And check that we are at the end and it's working. It's doing it on each frame. Don't worry for that. We are going to take care of this, although it's not that important. So it's working. Obviously, right now, what are we doing? We will call the end method, just like that. And if you want to make sure that it's working, you can do, so use game in the end right here. You can do a end just to make sure that we're calling this method here, and see it's working. Thanks to the hot module replacement, we didn't even have to do the whole level again. That's the whole point of this hot module replacement, and doing cleanup, good cleanups. You get the idea. We are getting so close to the end. Our game is almost done. Next is the restart. We are going to focus on restarting the marble when we fall from the level, okay? When we do this, for now. Later, we're going to handle the restart button. When we click there, I want to restart and be at the center. So let's go. First, we retrieve the information, I mean the method. So right here, just like we did for the end, we are going to do restart. See, when you did everything properly, it can go super fast. Restart, restart, and everything makes sense. And next, back to the use frame. So make sure you are inside the use frame where you handled the end. We're going to handle the fall, meaning that when we fall, it's when the marble y is below, let's say, a -4. That's one way of testing it. If the marble the y should not be below -4, because we are playing on the level, it's 0, 0. This one is positive, the y is positive. If it's below 0, it means that we failed, and we are not going to do the thresholds at 0. We're going to do -4, so that the player can really realize that he fucked up. Like, oh no, and then reset. Okay, let's do it. If body position, right now I just want to play with the game, but let's focus on the lesson. I'm supposed to teach you stuff, right? And we will do console log and do, yes, I'm starting to have a bit too much fun. Focus, focus, and check that. So let me check, yeah, minus, yeah, okay, less than, and it's working. Nice, I can do it again, I can move around, I can jump, it's still okay. And there, and it's working. So in there, obviously, we're going to call restart like this. And you can test it. Okay, let's test it. We've been testing the other ones. Let's test this one just to make sure that everything is fine. Restart like this, and I fall, restart. Okay, nice. Let's remove this little guy. Okay. As you can see, we are triggering those changes maybe too much time. For the restart, it will be fine, because if we restart, the ball will get back at the beginning. So we will only trigger it once. But for the end, like when we go at the end of the level, so over there, it will be triggered. Or if we are playing like this, see, I'm playing and I'm pressing the keys, and it will do start. So how do we fix that? There are multiple ways of fixing those. First, we could have like over there, let me see, where is the start? Where's the start? Okay, the start is there. In here, we could have tested the phase, okay? We could have retrieved the phase, and if the phase is already playing, we are not calling start, but we are going to do things a bit differently in order to learn a bit more. When calling set, so get back to your store, and that way everything will be in the store. I mean, most of the logic will be at the store. When we call set, so let's start with this one here. We want to limit those changes in the store, okay? We will do it right here. If the phase is already playing, we are not going to update anything. Otherwise, we are going to set it to playing. That's the idea, and we will do everything in there. But that means that we need to know what's the current phase, okay? To get access to the phase, we can do it by adding a state right here. Check that, state. You can log it, and there is no surprise. Check that. I will just move. See, I will press, I don't know, like left, and we get that. This is the current phase, okay? Sorry, state. Sorry, it's the current state, and in the state, we get access to the phase. No surprises, we get access to other method, and everything is just fine. It's just one way of accessing the current state. And using that state, we will test if it's like already, we will change to playing if the state, the phase is ready. Sorry, I messed up a little. So if state.phase equal ready, you can put just 2 equal. It's kind of the same thing. It's not true, but I will not talk about this. So equal ready. So if it's ready, we are going to change it to playing, but you have to return something in there. So to fix that, we are going to do return an empty object, which will result in updating nothing on the store. Okay, so if the phase is ready, so I will save and just do it now. Check that. Right now the phase is ready. I will move and it switched to playing. So the phase is not ready anymore. So if I press again, it will just return this. Okay? It will just return an empty object. Yeah, by the way, when you return something, it stops the function. Okay, so when we return phase playing, this one wasn't triggered. That's the reason why I don't have to put a else. All right, and we can do that with the other ones. Yeah, by the way, this can be written in 1 or 2 lines. I know it. I won't do it because I want you to understand clearly what's happening there. I don't like a super short version of many instructions. I'm not a big fan, but yeah, you can write this much shorter, and be my guest at the end of the lesson if you want to do that. Let's do it for the restart. It's exactly the same thing. We're going to do it together. So to the state, we provide a state argument so that we are aware of the current state. And in there, we are going to allow a restart if the state phase is playing or the state phase is ended. Okay, because if we are at the end of the level, the state phase will be ended, and the button will appear, and we want to be able to click on the button to reset. But if we are just falling from the level, we are currently in a playing state, phase, sorry, and we want to be able to reset too. Okay, so that's the condition. And in there, we're going to put ready. It was already ready. Yeah, it was. Otherwise, we just return nothing, so that we update nothing. And we can do the same with the last one. Let's do it again. State, if state.phase equal playing, meaning that we can only go to the ended phase if the current phase is playing. Otherwise, we do nothing. Okay, it's a bit overkill. It's a bit long to write, but if you shorten this, those functions, it's okay. And everything is encapsulated in the store. I don't mind adding that much code to have a clean store, a clean global state, etc. Not bad, not bad. We are almost there. The mechanics are putting together right now. Let's reset the ball finally, because we have a state we have been coding for quite a long time without seeing much on the screen. Fortunately, we were able to test with the console, but right now it's time to make our game adapt to that phase state. So we need the game to run. Let's focus on resetting the marble if the player's marble fall. Okay, let's do that now. In player.js, so make sure you're in the right one, we're going to add a reset function. I have no idea where to put this one. I will put it after the jump. Yeah, it makes sense. So after the jump, it's okay if you put it somewhere else. I'm going to add a reset function so that we separate things a little. And we're going to just console log reset to start with. Reset. Don't worry, this one is not going to be that complicated. We want to call that function whenever the phase changes to ready. That's interesting. That's our way of knowing that we need to reset. It's when suddenly the phase is ready. Maybe it was ended, maybe it was playing. We don't really care. Suddenly the phase is ready. Okay, I'm going to reset the marble. We're going to subscribe to it. And we've been doing subscriptions quite a lot, and it's the same thing. We need to subscribe to changes on the store, but unfortunately, for now, our store is very simple. Our store is only about properties and updating those properties. If you want your store to be able to handle subscriptions, which we need right now, you need to do a small trick. Check that. So in the usegame.js file, we're going to import something. It's the subscribe with selector. Okay, and it's from not just the stand, it's inside the stand. I don't know how we call this one, middleware. Looks like a folder. Anyway, you get it from here. I'm just going to log it because I have trouble writing subscribe. Okay, I wrote it perfectly this time. Next, what we are going to do is a bit silly. Check that. We're going to call the subscribe. It's a function. Subscribe with selector. It's a function, and we need to put, check where my cursor is right now. We need to put this function. So the function we provide to create. We need to put this one. See that? I'm going to cut it. So it's from there to there, this one here. I'm going to cut it. So we just have a crate right now. So it's inside my how do we call this one? My clipboard. I think we say clipboard. And we are going to call subscribe with selector. It's a function, and provide it in there. So why I just cut, I provide it in there. So at the end, check that I have one curly bracket and one closing curly bracket, closing parentheses, two closing parentheses, and there I have the create and the subscribe with selector, and then our function. I know it's a bit messed up. We could have create variables, okay, if you prefer, but just make sure that you have the same thing as me. Save, reload. If it's working, you did things properly. Otherwise, pause the video and check what you did wrong. So doing that made our store available for subscription. Just by doing that, that's actually quite convenient. Back to the player.js, we can now subscribe to the phase change in order to call the reset. And we can do that using the useGame, so the same useGame here, .subscribe. I know useGame is a function. Welcome to JavaScript. We've seen this kind of weird behavior, but this function we can also do, check that, subscribe. Like this, and this is another function. I don't know, that's super weird to have this in JavaScript, but you can do that, and they did that. This is just a function. So that's the way of subscribing to something. And to that subscribe, you probably guess what we need to send. We need to send a selector So we're going to select the phase and then a function that will be called when the phase changes. That's the idea. It's the same as we did earlier with the keyboard thingy. So let's go. We're going to do that only once at the beginning. So we're going to do it in the use effect. And I'm going to do it at the beginning of the use effect. So right here, use game, subscribe, and we're going to provide two functions, and I'm going to write them below. So here's one and here's another one. The first one is a selector. Remember what we are doing? We want to know when the phase changes to ready. So we want to subscribe to the phase. So we're going to select the phase. So state.phase, like that. And when the phase changes, we're going to simply log the new value right here. I can remove this comma here. Log, and I'm going to write something, I think. Oops. Log, like that. Phase changed to, and I provide the value, like that. I just want to check the new phase. So I'm not doing anything. I will move, phase change to playing. And if I go to the end of the level, check that. Phase change to ended. And I'm going to go back at the beginning without being squished under an obstacles, if possible. And check that. I failed. Phase change to ready. It's working. We have the phase telling what's the current state of our game. Nice. And in there, oh yeah, by the way, I forgot something very important. The cleanup phase, we need to clean that subscription. We're going to do the same as we did for the jump keys and the any keys. We're going to retrieve the unsubscriber. So it's going to be unsubscribe, the struggle, reset. Was it right? I need to copy and paste it. I'm not sure I wrote it right. Yeah, it was right. Nice. And then in the cleanup here, we're going to call this one like that. Okay, so we are cleaning the subscriptions and our component is magnifico. We can test if the value of the phase is ready. So yeah, let's get back to this one here. If the value, you should put phase. Maybe I'm not going to do it. I will keep using value, but you should name it phase so that you truly understand that that's the phase. If value equal ready, meaning that the phase suddenly changed to ready, we're going to call reset. That was the whole point of doing that. I know it was quite long, but it's because it was new in our store. Next time we want to subscribe to phases, which we will do together, it will be much easier. Reset. Okay, let's try. I'm going to fall behind and check that. Reset. So our reset function, this one here that we have right here, has been called when the phase changed to reset. Obviously, we don't want to just log something. We want to reset the marble. And to reset the marble, we're going to put it back at the beginning with set translation. But we also need to reset the velocity, the forces being applied on it. And we can do that with set lin vel. It's for set linear velocity to prevent it from moving. And set ang vel, it's for set angular velocity. We don't want it to rotate around. So let's go. It's quite simple. You will see. In there, we already have access to the body. Body current set translation. And it's a vector for it. So x 0, y 1, z 0. Like that. Next one, actually, you can give it a try, I think. We're going to fall and check that. It worked. But our ball is still moving because there are some velocities applied on it. So we need to reset those two with set lin vel. And we're going to put everything at 0. And set angular velocity. So this one here. So it's set ang vel. Yeah, like that. And it's a Euler if I'm right. And we put everything to 0. And check that. I'm going to reset. And it's perfect. Nice. Our game is working. The reset button, the restart button, sorry, it should not have been a reset. The reset button is always visible and clicking on it doesn't do anything. Okay, I can click that, it doesn't do anything. We're first going to handle the click and then toggling it, handling its visibility according to the phase. So reset on click, actually, maybe you should do that. All right, maybe pause the video, maybe you're super tired, do a break, but try to handle this. When we click on it, what should you do to reset the marble? It's not that complicated, but still you have to find exactly what to do. So first it's inside interface.js. In there we need to access the store, and that's why we created a store. We need that information everywhere. So import use game from the store, and I will add JS at the end. In there, we need to have access to the restart method from the store. So const restarts equal use game. We provide a selector and it's the state, and we just want the restart like this. Okay, and that's the way of accessing the restart method. Next, in the button, so it's the restart button here, we're going to do on click. It's the usual, like it's traditional React. We provide to that on click the restart method. You don't call it this one, okay? You just provide the function. Don't put parentheses. So restart like that, and check that it's working. So easy. We are calling restart on the store when we click on that button, and doing that, check that, we'll call so this method here, which will set the phase to ready. And when the phase changes to ready, our player in there, this function will be called. So the marble will go back to the initial position. Makes sense. And it was really easy because everything was set properly. I have to reassure you, when you do games for the first time, it's not that clean and straightforward. Okay, it takes time. Just like I spent many hours on that game trying to find the perfect structure. You don't get this on the first attempt. So yeah, we did that already. Next, we want that restart button to only being displayed when we reach the end of the level. We need to know the current phase. So in interface, this one is going to be going to go quite fast. You can try it. Okay, I'm going to hide this this one here. It's not too complicated. You want to show this restart button only when the phase is ended. So let's try to do that. We're going to do it together. So let's go. First, we need to retrieve the phase from use game. We select only the phase, and we're going to make this restart button optional. Remember how to make a component optional. I'm going to cut it. I'm going to inject something, and I'm going to ask, is the phase equal to ended? Like this. And there is two ways of handling this. You can use a ternary, like yes, no. So for the no, we put null. And for the yes, we put the component, okay? The component will be returned if the phase equal ended. Or you can use the other techniques, which is a bit silly, but I kind of like this one. It grows on me. It's the double %. You know this one? We've explained it already, and you just put the component in there. And the component will be displayed only if this is true. And I'm saving. See, it's already gone. I don't even have to reload the page. That's the magic of writing proper components, and see, the restart showed up. It was quite a rough show up, but we are not going to do some fades and spring animations, etc. The lesson is big enough. I don't know, it has been maybe like 4 hours, something like that. Next, we need to handle the time. Be careful, the time is a bit harder to handle. We want it to start as soon as the player starts moving. So right now, the time should be 0. Okay, if I start moving, it should be it should start, so 1, 2, 3 with the decimals, and then when I reach the end, so like this, it should stop so that I have time to see the score, how long it took me, and I can take a screenshot and share it on Twitter or whatever. So that's the idea. That's how I decided the game could be, but you can do some very different behavior. So we could save the elapsed time in the store. All right, that's actually what I did initially. So in there, in the use game store, I had the elapsed time. Okay, elapsed time. And I was updating that elapsed time depending on the phase from the player.js file. What's the issue with that? Can you guess it? The issue with that is that we are updating the store on each frame. And it's not necessarily bad, especially if we use selectors properly. All right, because until now we have been using selectors like when we want the blocks count, see this one, we just retrieve the blocks count. So if there is a props like the elapsed time that update on each frame, this component won't re-render because we are only getting the blocks count as a reactive data. If the blocks count changes, yes, this component will be rendered, but that's the only thing that can, the only data from the store that can re-render this component. So it's fine. But let's not rely on the good coding skills of everybody, and let's try to avoid, if possible, updating the store on each frame. In case, I don't know, another developer is listening to any change on the store and re-rendering the component in that case, the component will be re-rendered on each frame. It can be very bad for performances. So instead, we're going to save the start time, meaning that right now we don't care about the start time, but if we play like this, right now we save the start time. Okay, it's kind of a timestamp, like a date with the minutes, seconds, and milliseconds. And when we reach the end of the level, like this, tack, we save the end time, and we will just use those two values. Like when we are at the beginning, we display 0. When we are playing, so the phase is playing, we take the time now and we do a quick math. It's a subtract to compare it to the start time. And when we are at the end, instead, the quick math formula will be that we do an end time and we subtract the start time. That's all. So that in the store, we only save the start time and the end time. If it makes sense, it will probably make sense once you have it running. So in there, we're going to add some informations. I'm going to add them above the phase. Why not? And it's about the time. It's about time. Good one, Bruno. So I'm getting tired right now. Start time is 0, end time is 0, like this. And we're going to update those according to what's happening in the scene. And actually, that's the cool part. We don't have to update those in the player or the interface or wherever. We can do those directly from the method, because when we switch to ready, it means we start playing, so we can save the start time from here. And when we reach the end, so this one here, we can save the end time. So that's super cool. How do we access the time? Well, we can use date now. I think I already showed you this one. Check that. Date now. See that number? It's what we call a timestamp. It's kind of a date. It's how many milliseconds, if I'm right. Yeah, I think it's milliseconds, since the 1st January 1970. I'm not going to go into details, even though I want to explain to you this. Just Google it. Timestamp. Okay. So it's just a time, and see that it's going up, going up, going up, going up. Okay, it's milliseconds, so this one are the seconds. So it's 3, 4, 5, etc. Okay, great. So it's kind of a date in the milliseconds. And we're going to save this date in the start time when we start. So when we go to the playing phase. So let's go. Start time. Date.now. That's why sending store values like this is not that overkill, because sometimes we need to send multiple values. So we need to send the new phase and the new start time. And we can do the same with the end. I think it's over there. Yeah, make sure it's not in the restart. We need to do it in the end method. Right here, we're going to send the end time, and it's going to be date now too. We just save the date when we started playing and the date when we finished the level. And then we are going to display some calculation in there in the interface with minimal store updates. All right, let's move forward. We're going to update the interface. So get back to the interface.js, and we want to display the time according to the phase. So first we need to get access to the phase. Do we have the phase? Yeah, we already have the phase, by the way. There is a trick here. We want to update the time on each frame. Do you know why? Well, because when we are at the beginning, it's 0. Okay, but when we play, it needs to update on each frame. And we want something very precise to kind of stress the player. So we need to execute something on each frame. So you might think, yeah, let's import use frame from React 3 Fiber. But what's the issue? We are not in React 3 Fiber. Remember that? See this? Interface is not in the canvas. Interface is not in React 3 Fiber. So how can we update this one? If it was like a native JavaScript, we could have do a request animation frame. Yes, we can do that in React. It's a bit silly, but we can do that. But I have good news. There is a solution for that, but we will see that solution a bit later. First, since we are going to update the time on each frame, we are not going to rely on the how do you call this, the reactive behavior of the component. We will do it by updating ourselves this text here. So meaning that we need a reference to that text. So it's over here. We need a reference, and we are going to update it using a native JavaScript, not React. So let's go. First, we need a reference because we want to update it ourselves. We're going to do import use ref from React, like that. We're going to create a new reference. Yeah, at the beginning, why not? So const time equal use ref, like this. And we're going to associate it with this component here. So it's going to be ref equal like that, okay? Because we want to update it ourselves, not with reactive data, to prevent having too many re-render. Okay, that's done. We want to be able to update. Yeah, that's what I just said earlier. So we could create the request animation frame over there. It would be a bit silly because it's outside of React and we need to make sure that we destroy that request animation frame loop. It's super silly. But I have good news. React 3 Fiber got us covered. We can't use frame, but we can use add effect. Add effect will be available outside of the canvas, and will be it will be called right after the use frame is being called. So that's perfect. That is exactly what we need. So let's go. We are going to import it. It's going to be import add effect from React 3 Rapier, and I can show it to you. Check that. Let me check. We already we want to do that only on the first frame. So from React we need to do it in we need the use effect, the classic use effect to be able to do instructions only after the first render, not the first frame, sorry, the first render. And in there I will put the code right here. We're going to call use effect with the usual empty dependency array. So this one is being called only on the first, after the first render. And in there we will be able to plug to the frame rate of the React 3 Fiber. Doesn't make sense, but you get the idea, by sending a function to add effect like that. Okay, it's a bit like use frame, but it's called add effect. We can do it outside and we have to do it in only one time. And in there we're going to do tick like that, and check that. We have a ticker. We have a function being called on each frame, and it's being called right after the use frame. So that's perfect. But we made a mistake. If the component is being redrawn, I mean disposed and added again, like, I don't know, we do some changes or for some reason we remove the interface and put it back, this one will be called again, okay? And we will add more add effect, and we have two ticks at the same time, and then 3 and then 4. It's the same. We need to unsubscribe, and you guessed it, they wrote that function as they should, by sending back an unsubscriber. Okay, so we're going to retrieve the unsubscribe by doing const unsubscribe effect, why not, equal add effect. And this is just a function to stop listening to that tick. So in there we're going to do the classic cleanup phase. So return a function, and in that function we're going to call unsubscribe effect. We are cleaning up things. Okay. Yeah, by the way, we can make this one much smaller. Okay, but I would try to keep everything the same way as the rest of the code. So that's the reason. Okay, we are almost done. We have some calculations to do. In add effect, so in this one here, we need to access the current state, okay? We need to access to the phase, to the elapsed time, I mean to the start time and to the end time. How do we access those? There is a mistake that we could have done. See that? The phase here, we can't use it here, okay? The issue is that we only subscribe on the first render, and this one, this function here, will be associated with the data at that time. When we started, we subscribed to the tick. So the phase will never change. Like, check that. I can show you the phase right here. It's ready. I will start moving and it's still ready. Yes, because this function is using the scope from the old code of the user interface. So it doesn't make sense. Don't worry, it's quite easy. We just need to access the state in a non-reactive way. We just want the state, like use game, provide me the current state and don't ask any question. That's the idea. And we can do that. So const state, we already have a use game imported. We're going to do use game get state, just like that. Okay, and we're going to log it. See that? And now we have access to the state, the current state, without asking any question. And we can do state.phase and check that now. it's ready, it's ready, it's ready. I'm start moving, it's playing. Okay, that's kind of a silly way to access it in a non-reactive way, and it's perfect in our case. So we're going to create an elapsed time variable and set it to 0. Let's go, let's do that. So instead of that, we have the state. Great. Let elapsed time equal 0. Why let? Because we are going to update the elapsed time according to the current phase. If the phase is playing, we're going to do to subscribe start time to the current time. So right now, you understand when it's working. So if state phase, meaning that we are playing right now, equal playing, we're going to set the elapsed time to be date now, so right now, and we subtract the state.start time. Okay, and if, I mean, else if, check that, else if the state is ended, we are going to subtract, so it's going to be state.end time to it. So by default, like this, elapsed time will be, can you guess? It's 0 because we are in the ready phase. So it's not this one, it's not this one. If we start moving, elapsed time will be equal to this one, and it will be like right now, to which we subscribed when we started. So it will be 1, 2, 3, 4, 5. And when we reach the end, it's going to be the end time. So it's going to be this phase here, end time to which we subscribed start time. And we're going to send that to the time because we already have a reference. But first we need to do some fixes on it because those are milliseconds. So first elapsed time, we're going to divide it by 1000, sorry. And this can be super precise. Check that, I'm going to log it. See? It's a bit too precise. We can change that by using toFixed. So we're going to do elapsed time. Like this. Elapsed time equal elapsed time toFixed 2, meaning that we want only 2 numbers after in 2 decimal numbers. And check that, we can log it again, like this, and we get this. And when we start moving, we get this. And also it converted to a string, which is just fine. I'm happy with that. And when we reach the end of the level, it stops, and it always provides the same thing. In rare case scenario, add effect can be triggered before the reference is ready. We need to be careful with that. I don't know how to reproduce that bug, but I know that it can happen. So in there, we're going to update the time using the time reference, so this one here. But first, we need to make sure that this one is available, just in case. So we're going to do if time.current, then in that case, we're going to update it. So time current text content equal elapsed time. Oops, sorry, it's not a string, it's like that. So we are updating this one only if it's available, just in case. So it's 0, 0, 0, 0, 0, we're just putting 0. And when I start playing, check that. It's working, yay! And we can go at the end of the level, and 5 seconds, perfect. Nice, we are almost done. Next is kind of an important feature and a funny feature. We need to randomize the level, because when we restart, see that? I get the exact same level. I can show to you. So it's limbo, axe, limbo. I restart, limbo, axe, limbo. And it's a bit boring. We want to provide a different set of traps to the player so that he can't just try to find the best way every time. To fix that, we're going to do it on the use memo in the level. Why? Well, check that. In there, when we create the set of traps, we just do like some kind of randomized traps. And we're going to play with that one here. We're going to provide another variable that will change. We can put whatever we want as a variable that will change. And since that variable will change and be part of the dependencies, use memo will be called again. What we put inside will be called again, and we will get a new set of random traps. So how are we going to do that? We are going to call this one the block seed. Okay, we're going to do it in our store. So let's go use game at the beginning. We're going to call it block seed and just provide an initial value to 0. Okay, and that block seed, we're going to retrieve it in the level and provide it to the dependency of use memo. For the Minecraft fans and other procedural generation fans, I know this is not a real seed. Okay, this is not a real seed because we are not using any pseudo random numbers, etc. But let's not be too picky and consider it as a seed. When this one changes, the level will change. We will get a new level. Okay, so in level.js, add a seed props. Yeah, we're going to use a seed. And by the way, if you want to create a real seed, be my guest. So that every time you provide the same string, you get the same level. And if it's a different string, you get a different level. But if you provide the same string, you get the same level. So let's go. On the level, it's going to be over there. We're going to provide a new prop. It's going to be seed, and we set it to 0. Because I know first then we use that seed on use memo, so that if the seed changes, use memo will be called again. That's the idea. It will break the use memo cache. It's not a cache, but you get the idea. Next, in the experience, since it's a prop, we need to provide a prop. In there, we're going to retrieve it. So let's be lazy and duplicate the blocks count. It's going to be the blocks seed, like that. And in there, we can provide the seed to the attributes. So seed equal, and we provide it. Okay, for now, we have the exact same result. The seed is 0. And even if we die or we end the level, the seed is still 0. All we need to do now is update the seed to any other value so that it will change there. It will change there, and it will break the use memo in the level. So how can we do that? In the store, that's great because it's still encapsulated in the store. In the restart method, so right here, we provide a new block seed, and we are just going to send a random value like that. Okay, you set it to ready, and you provide a new block seed. And I'm going to give it a try. So see, I have those 3 things, so a spinner and 2 limbos. I'm going to die, and we have a new set. And I'm going to die, and we have a new set. And I'm going to go at the end of the level. Oops, like that. I'm going to click restart, and we have a new set, and it's working perfectly. Nice. We are kind of done. Let's put back the blocks count to 10 so that we have kind of a challenging game like this. So see, it's a bit longer. We have to go at the end. Oh, not bad, not bad. Yeah, let's go. A bit above 5. Not bad. And now we have a new set. And we are done with the actual base game. But we're going to go a little further with the concepts, and we're going to make it pop. Don't worry, it's going to be quite fast. We are almost done. I just want to have a bit more fun and make the game slightly more better in this section. See, it's almost the end. First, we're going to change the background because the default one is the one that we see in the page, and it's white. We're going to put, I think, something kind of blue. So let's go. We're going to do it in the experience. In there, we're going to add a color. It's the same thing. We have done this quite many times. We're going to send an array with a color, and you can use my color or whatever color you want. Use mine because later we're going to change it. You will see why. We provide as the we attach it to the background property of the parent, which is the scene. Just like that. Okay, it's blue, a nice clear blue sky. Next, we're going to add a title right here so that we can just provide the name of the game and people will understand what it is about, even though we kind of understand with just watching the game. So let's go. In level.js, so where is our levels? It's right here, so level, singular. We're going to use the text helper and the float so that we just have a good looking text that will float around like this. So let's go. We're going to import those from Dre. Have we used Dre? Yes, for the GLTF. So float and text. Yeah, I'm going quite fast because those are super easy. We have done those already quite a bunch of time. You can actually try to do that on your own. Add a text here and put whatever name you want for that game. So I've imported float and text from Dre. I will go on the block start and see when I told you that we're going to use that group at some point. We're going to add the float and we're going to add the text like this. And I'm going to provide a scale of 4 and set the name to marble race. Okay, and we get this. It's on the floor. We need to do some tweaking, but it's working. Nice. First, I provided a font in the public folder. So it's the Bebas. No you, as always. I really like this one. I'm going to add some line breaks. So it's not on the float, it's on the text. Let's not do mistakes at the very end of the lesson. So font in here, we're going to provide a string. It's going to be /. I forgot the dot right here. Bebas Neue. I'm not sure we say Neue anyway. V9 Latin regular. Well, I kept the original name anyway. Let's check that. Yeah, okay, it's working. That's the new font. And then I'm going to add a bunch of attributes to make it look better. So max width, so that it's on multiple lines, is going to be 0.25. Line 8 is going to be 0.75. Text align is going to be right. You will see the result. Just take my parameters, and if you want to tweak them, you can. Position, I want it to be a bit on the side, so it's going to be 0.75, 0.65, and 0. And finally, a quick rotation on the Y is going to be minus 0.25. And what we get this. Okay, it's working. We have the name over here. The text is too dark because it's using mesh standard material, but also because there is a tone mapping being applied on it. So we need to fix that. We're going to use a mesh basic material and deactivate the tone mapping. And to add the mesh basic material, you just add a mesh basic material. And we've seen that. And we set the tone map. I'm going to auto close it already. And we set the tone map true so that we have a nice white color. It's like fully white. And we get this. Okay, that's better. We can reduce the float because it's a bit too intense. So on the float, we're going to set the float intensity to 0.25. This is for the position. And the rotation intensity, we set it to 0.25, like that. Okay, so that it doesn't move too much. And we are done with the start part, and we are all going to do a very similar thing for the finish line, so that when we go at the end over there, we can see like the finish title on top of the finish line, and we can see it over there. Okay, that's the idea. We can duplicate it, so let's add a finish title at the end. Yeah, no, actually we don't need to duplicate it. In the block end at the beginning, this one is not going to float, so that we clearly see where is the separation with the end. We're going to do text like that. In there, we're going to write finish. We're going to set the same font. So font equal Bebas. Oh no, I don't want to write it again. So I'm going to copy this one and be super lazy like that. The scale, it's going to be bigger. I think it's twice as big. 8. What did I say? 9. You can move forward. Yeah, okay, it's there. That's the whole point of having a hot module replacement and a good cleanup, etc. You can just move something at the end of the level and you don't have to reload the page. So it's right here. We need to change the material in it, so we can use that material, the same material, mesh basic material with tone map to false. So right here, like that. Okay, much brighter. And finally, we can move it. So it's going to be, oops, I clicked on restart, obviously. But anyway, let's do it. Let's add the position. So position equal, and I'm setting an array, XYZ, 0, 2.25, and 2. And it will be right at the edge of the block. So like this, not bad. Yeah, see, it's right here. And it's right above that line here, which makes sense, so that we understand that this is the exact limit to finish the game. So good, we are almost done, just a bit more. We're going to add some post-processing. And we are going to add a depth of field and a reflection. This is the moment where it will have quite an impact on performances. You might hear your fans in your computer start turning super fast. It's bonus, so if it's too much, just don't add it. It's just fine. But I wanted to have some fun, to finish on a high pitch. I don't know how you say, on a good finish. So in the terminal, first we need to add post processing. So let's go. I'm going to add a new terminal. npm install React 3 post processing, and I'm going to force the version 2.6. I'm going to zoom in a little. Oh no, sorry, zoom out a little. Yeah, like this. So npm install React 3 post processing, the version 2.6. Make sure to use the same version as me to prevent surprises. If you get errors, you can ignore the vulnerability warnings. Let's see. Okay, it's working. I'm going to close this one, hide the terminal, and move forward. So first we're going to put effects in a component. Why? Well, because check our experience.js. It's so clean. We have almost nothing to instantiate our game. I don't want to mess that up. So we're going to create a component for the effects. And because we will have quite a lot of lines. So let's go. We're going to create a new component. So where is my sidebar? Okay, it's there. I will create effects. You see that a lot among React 3 Fiber developers. They call it effects, which makes sense. export default function effects like that, and we return null for now. Okay, save it. Back to the experience, we are going to import it. So we duplicate this one, call it effects. Be careful, there is an S, say effects. And we are going to add it, and we can add it outside of the physics. Okay, we don't need the effects to be inside the physics. It wouldn't change anything, but it doesn't make sense, so I'm going to add it outside. Actually, the light could have been outside too, I think. Yeah, quite sure of it. Okay, so we have our empty component working, and we're going in there to add the effect composer thingy. So let's go import effect composer from the library we just added. So it's React 3 post-processing, like that. It's the classic effect composer. Just if you don't know what we are doing right now, just check the post-processing with React 3 Fiber. In there, we're going to open it and close it, and we are able to add the effects in there. By the way, I didn't add bloom. I really wanted to do it, but I said, no, it's too much. We have to calm down. So if you want to add bloom, be my guest. I would love to see some levels with the bloom. Please do that. At the end, create some cool levels with good-looking bloom. I don't know, maybe the obstacles are blooming so that they are dangerous, like it's hot or whatever. Have fun with it. Next, we're going to add the default field. It's going to be quite easy. We're going to import the effect. Remember, we talk about effect, not passes. And we instantiate it inside, and we're going to provide the values directly. Okay, it's we are tired enough. Let's just provide a bunch of values that will look good. 0.01. I just tested those values. That should be fine. The length is going to be 0.2, and the bokeh scale is going to be 3, and it should look good enough. Let's see. We get that. See, it's blurred in the back. So we have the default field. Super nice. Next, we're going to add the reflection, and I think that's the last part, the very last part of the whole lesson. To add the reflection, we are going to use the SSR, obviously. So let's go. We are going to import it. That one that really kills your GPU. It's the SSR. So let's go. We are going to add it before the default field. Why not? I don't think it's that important. Let me think. No, it has to be before this one here. Makes more sense. So SSR, by default, it doesn't look good. Yes, I know there is an error over there. You can ignore that error. I think it's linked to how the marble is, I mean, the SSR will do some tricks with the shaders, and maybe it doesn't work with not the marble, sorry, the text. You can ignore that error. It's not an issue. About those parameters, we are not going to set those parameters individually. What I recommend you is right now you pause the video, you scroll at the very end of the page right now, and you take those parameters, okay? I'm quite sure it's the same as we put in the post-processing lesson. So I'm just going to be lazy and copy them in those parameters, I mean those attributes here, like that. I'm going to test. Are you ready? No, it's not working. Do you remember what was missing? We need to play with the material properties too. So get back to the level. It's almost done. Check that. Get back to the level, and in there we need to set the metalness to 0 and the roughness to 0. I mean, it depends on the different components. So let's do it for this floor here. So the first floor, we're going to do metalness 0 and roughness 0. For the second one, we're going to set the same thing. For the third one, what's the third one? It's the obstacles. We're going to set the roughness to 1. And for the last one, we're going to set the roughness to 0. Okay, you get the values, the properties I put there. It's almost 0 everywhere except for the obstacle, because we don't want the obstacle to reflect everything around. We won't be, I mean, if it's a mirror, we won't be able to see it. We can save, we can give it a reload, and it starts to work. You can see something on the edges, but it's barely noticeable. It's not bad, but we can't see them clearly. What you can do is change the colors too, and you can use those color hairs, which are darker colors, making everything more visible, I mean, in terms of reflections. So let's go, this one, this one, this one, this one, and this one. Let's be lazy, just take my values, and it should look like this, and check that out, and we are done. Congratulations, now you can play, now you can sleep, now you can share what you built with the world, and it's working, and we have reflections. Be careful. This one is putting quite a lot on the performance, so make sure that it's working properly. Maybe deactivate the SSR if it's too bad for the performance. By the way, yeah, the sky is a bit too bright, so in the end we haven't really finished. So on the experience, set maybe a darker sky like this, and it's much better. Nice, looking good. You can also tweak the lights, etc., but we need to stop at some point. Still, I'm going to give you some insights to go a bit further. First and most important point, I want to know if you are able to finish the whole level in less than 5 seconds. Okay, if so, just prove it to me, send me a screenshot on Twitter. I will trust you not to cheat, and I want to know if you're able to finish it in less than 5 seconds. I was able to do it maybe twice. Not bad. I won't say how many times I had to try. The game we created is working. We have all the mechanics, I mean the minimal mechanics, but we can do much more. We can improve everything, and I want to improve everything, but I had to stop at some point because the lesson is quite big already. But I'm going to provide you some ideas. You probably had many ideas on your own, but I'm going to give you my ideas, and I hope to see those at some point. I mean, have fun, improve it, and send me the result. I want to see the result. Just tweet it, use the 3GS journey hashtag, and I want to see what you will build with that. So for the ideas, I already told you about making the traps glow with the bloom. Maybe get rid of the SSR and depth of field and use the bloom instead on the obstacles. I actually already tried and it looks super cool, but I want you to do it on your own. You can make the obstacle look like actual balancing axe. Yeah, about that axe, it was a bit disappointing not to have a real axe like in dungeons, so maybe make obstacle a bit more attractive by creating like a real axe that does this. You can create more traps. That would be funny. We have only 3 variations. We can add more. We can add control over the size of the traps, because currently we put 4, like 4 a bit everywhere in our code. It's working, but maybe you can control that through the store. How great that would be. This way you can make the traps bigger and smaller with just one property in the store. You can add a better scenery, you can add some textures, things like that. In terms of gameplay, you can add a boost key. That would be funny. Maybe you can have only one boost and it will just push the marble fast forward. You can have boost bonuses, like, I don't know, some items. Instead of a trap, you have an item, and if you get that item, it will boost you, or maybe change the time or whatever. You can have different difficulties with different traps, or more levels or whatever. You should add sounds. I mean, it's a game. We should add sounds. Be careful, you can't play sounds if the user didn't interact yet with the scene. This experience is missing particles. You know how much I love particles. I didn't add particles. I'm a bit sad about that. Please add particles. Maybe marble customization. I don't know, like we can change the color or add some effects like in that game Rocket League. Maybe something like that. And lasers that can kill you instantly. I don't know, put whatever you want. I have a lot of ideas. I'm sure you have some ideas too. And we are done with this lesson. Congratulations.